Alright, there we go. Hey everyone, NPC scientist Haruka Itsumi here, and how's it going today everyone? Today we're going to be doing something a little bit different from the usual. Now so the way this was described to me is kind of like machine learning, but in a puzzle game situation is what I understand it to be. Seems like we got several buttons here on the side. I'm kind of covering it. Let me move over just a little bit so you can actually kind of sort of read it. But anyway, let's just check what we got here. Settings. Controls seem to be mostly mouse and some keyboard things. Alright. Not much, not too different here. But education, it seems like there is... Okay, there's a video on how to learn basics. Go deeper into machine learning step by step. Okay, so it is correct. There is a machine learning aspect regarding this. And it pretty much, I think, it pretty much encourages you to learn Python for the programming language. I wonder what the rest of these things are. But anyway, before we start, I just gotta say this. I don't know any machine learning per se. I've looked into it a little bit and I think it's neat. So I guess for machine learning to actually work really well, you would need some kind of database to store all the learned knowledge as well as a continually running script, right? But saying that, machine learning is not really something I've done before. Despite looking into it a little bit. Is it something I want to learn eventually? I think it would be neat. At least some simple machine learning and then maybe expand from there. Who knows, maybe that might be interesting. We could probably try doing a stream about it as a thing to explore together. Part of the thing I want to do in the channel is just exploration in general. It doesn't have to be games or anything like that. Just general exploration would be nice. I would think that would be nice. And let's see. So I have done a little bit of programming before, a little bit of web development mostly. I have developed a website from scratch. I have also done a few web apps for... I mean, it's not public or anything. This is more like a utility stuff for laboratory things. And yeah, I've done that. It just takes a while because of all the things I gotta consider, all the mishaps that the users will do. Yeah, there's stuff like winks and all that stuff, but it's like if you want full control over everything, you gotta build it from scratch, right? But for the general public, they don't need to do that. You just need a plug-and-go website to display your goods, services, photos, whatnot. It works just as well. But anyway, let me get a little water here, and then we're gonna get start. Alright, so I haven't started this game before. Let's see what we can actually get, because the concept seems interesting to me. Where you're making a machine learning thing using a game. But yeah, let's go ahead and start. It's been about 5 minutes already. Tutorial, sure. Let's start with the tutorial. To become a programmer, you must master your art of turning the computer on. I guess you gotta start somewhere. Press and hold the flashing triangle and drag to connect the power outlet with your PC screen and keyboard. Need an Oxford comma. Always use the Oxford comma even though you don't think it's necessary. When it's done, press power button, and that will appear in the upper right of the screen. Okay, I need to bring my screen down a bit because there's wires in the way. Congratulations, you're almost a programmer now. Oh boy. I would be surprised to... Okay, so here's our power supply, here's our PC tower. I guess we gotta start somewhere. Let's connect the PC and the monitor, as well as a PC and the keyboard. Time to cross fingers and turn the power on. Let's turn the PC on. Yay. We have classic Windows, wallpaper. One more step to be a programmer. Okay, what is it? Alright, so here's our main character here. Our programmer who is working way late at night. Looks like it's about 10... It's either 10:15 in the evening or morning. It's a little difficult to tell. Or almost 3 o'clock. Okay, looks like we ran into a bug. And bugs are never good. Bugs are never good. So what are we gonna do with this? Okay, put the coffee down and let's figure out how to work with this. I can't figure it out. It's like this bug is so hard to squash. What the heck, man? Alright, let's take a break from this, refresh our mind, and come back later. And this seems like our cat is just kind of peeking at us. Alright, let's get some coffee. Coffee is good unless you don't drink coffee like me, like I don't drink coffee. Alright, okay, so our cat is coming to our computer. Normally if you have pets around and they come to your computer, it's usually to sabotage things, but in this case... Seems like our cat is doing the programming for us. Man, I wish pets did that. That would make things a whole lot easier. And then we come back and it's like, oh, what the heck? Did you do this? Build successful. Well then, it seems like our cat is a lot smarter than we are, or at least can see our flaws a lot easier than we can. And cat is there like, dude, you could have done... This is so easy. How could you not do this? And it's like, okay, let's see. What's going on here? What's going on here? Look at that cat. It's so smug. Cat is smug right now. And we are just staring in awe. What did you do? Did you do that? Meow. 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 Holy zeros. If only I could understand what this cat has to say. Meow. It's so smug right now, though. I guess we'll have to find a way to recognize your speech. Meow. Goal. Cat speech recognition to-do list. Google it on Cat Overflow. Of course, if you can't figure out the answer, maybe Cat Overflow will have it. Always check Cat Overflow because someone's bound to have posted a solution or something similar to it, right? Oh my gosh. If you don't know what Cat Overflow is, it's a parody of Stack Overflow, and generally people use it for mostly programming stuff. Programming questions like, I am stuck on this, why does it not work? Also, it's also good for Excel stuff, and they have multiple boards for multiple subjects. It's not just programming, but programming is the main focus of Stack Overflow. There are other boards for like D&D, Star Wars, but the main catch of Stack Overflow is you are encouraged as a user to see if a solution already exists for your problem, because repeat questions are gonna be squashed right away. Oh my gosh, so thirsty. So yes, we're gonna Google it on Cat Overflow. Maybe they can help. Okay. They don't have answers for us. Okay, what's my name? Let's go with my name. Haruka Itsumi. We're registering on Cat Overflow now. Let's double check that we're actually live. We're actually live. Okay, recognizing animal speech. Hey everyone, can you believe my cat? The little devil has debugged my code again. So this has not been the first time? Okay. That's a little bit odd. He definitely has something to say, so I decided to make some sort of system, algorithm, which would help me understand him. Give me advice. Wish me luck, maybe? I'm not insane. My mom had me tested. Press F5. Okay, fine. We'll press F5. Don't rush ahead of yourself. Making a device that would be able to detect the cat would be a nice start. You can work with videos, sounds, etc. when the time is right. Okay, so we gotta record our cat first. Maybe sound would be the best option. Doesn't have to be video. Hey, a couple of days ago, I've been reading about how expert system can be applied for detecting animals and writing chatbots. The newspaper was called Deep News. I'll be sending you my copies once I'm done with them, and this is actually fairly true. A lot of people on Stack Overflow are very, very helpful. It is surprising how helpful they are. Kudos to them, kudos to them. Alright, welcome to your workspace. It is where the programming magic and bugs, mostly bugs, all the bugs, is born. To begin, drag an expert system from the node. Okay, so we have an expert system over here. Our expert system seems to be a recorder, so drag a connection line from the starting node to the expert node. Input from camera. Okay, so we're actually using a camera. And then photos with cat, and then we're going to connect with photos with no cat. Click test run to see if the scheme works properly. Okay. I'm not sure how to tell if this is working properly or not. Something says 100%. I don't know what that is. I'm guessing this is number of samples. Well, that is true, because with machine learning, the more samples you have to work with, the better the machine, the better the program, the code will work. Time spent, 21 out of 26. I guess there is a time limit to these, or at least some kind of time measurement. Hey again, I've tried that expert system and it hardly makes any sense. Squares are floating from left to right. Is that what the fuss is all about? Is that what the fuss is all about, machine learning? Are you guys actually working there? Is this the same guy? Yeah, it is. Okay. Don't rush, but friend. You gotta master your machine learning ninja skills first. Oh my gosh, this voice is perfect for this guy. I'm working as a freelancer and the amount of contacts is crazy. I'll forward you some jobs if I don't have time for. I'll forward you some jobs that I don't have time for. It will help you get on your feet and earn some cat bucks as well. Check your mail now. You're still paying for the service though. Sad. Haruka Itsumi at cat.meow. Noob advice. There's an auto help for each new technology. Very convenient. I've turned it on for you now. No need to thank me, but you probably want to change your password. My cat talks 123 is pretty obvious. I don't know how obvious that actually is, but it is a fairly unique password. And someone hacked our account. What the heck, man? Don't hack people's account just for funsies. Task tree. This is the map of your progression in the game. Vertical progression stands for story quests. Horizontal progressions are optional. Icon colors stand for different types of machine learning text used in respective tasks. Sounds pretty simple, or so we hope. Okay. Unless there's something special about the horizontal branches, like we get some part that we won't get otherwise, we're probably just going to focus on story quests. Though, if we can finish some of it along the way, I wouldn't mind trying it. An extra challenge is not bad for the brain. Is not. Alright, let's see. Applicants. Spanish school at cat.meow. Everything is cat.meow. So I'm guessing Kugo is using .meow .meow extensions now. .meow domains. Applicants, good day. We're from a public school. Summer exams have ended, and their results are attached to the letter. Could you process them and predict which of the students will be able to enter the MIT? The MIT reward 350 cat bucks. That seems pretty good. See these colorful geometric shapes? They represent various kinds of data, numbers, letters, elements of images. In modern world, everything can be turned into data, and machine learning is all about sorting and interpreting data. This is also very true. Long story short, your goal in the game is to transfer data from the left part of the screen to the right. These bars show the minimum amount of data that need to be processed to complete the task. Ah, I see. Okay, that makes sense. Alright, so, I mean, we've done this earlier. We just connect this and this and this and this. Runs expert system. Now, I don't know what this means. I guess we have to change it to something. So this is green, this is red. Is red what I need here? Let's test it. No, that won't work in this task. Try changing the color value in the upper part of the expert system node. Okay. Okay, there's no red, but there is a green and blue. I guess that's what's happening over here. Okay, let's try that. So there's some green. We're and whenever we get a blue, it gets processed to the bottom at a slower rate. And I can't change it as it's going. Release the program to complete the task. Okay, looks like we completed this. Accuracy is 100% out of 100%. Nice. Why did we... Oh. The cat cloud takes a cut from our reward because we got to pay server costs. Gotcha. Gotcha, that makes sense. Makes too much sense. Too real. Too real. Errors in the database. But before we do that, what's this over here? CBay. Does nothing. Has test v SkyROM and pre-installed SkyROM. Mandatory for purchase. Do I have to? I don't want to buy SkyROM. Come on. Let's see. What's this? Locked. Hardware. 1 megabyte of RAM. Oh, wow. Servers 2000. Rentium. 256 RAM, that's not bad. 300 gigabyte hard drive, that's actually not terrible. Okay, looks like we got a bunch of parts, but we gotta buy the plant first before we do anything else. Like, what the heck? Cat skins. Get a cat, only if you find the way. Some don't recognize it when they do. Some don't ever want to, the Cheshire Cat. We got Tourist Cat. Let me see what Tourist Cat is. Oh, it opened up a window on my side of the screen for language patches, it seems. I see, so that's what Tourist Cat is. What is Cheshire Cat then? So it opened up another thing. It says, join Wild True Learn Friends Club. You will receive a unique kitty promo code. I'll do this one later, but that seems interesting. Alright, let's go by the aloe. Because I don't think it's going to let us do anything. Hide in room. Hide purchased items. Hide locked items. I think that'll be okay for now. Why is it locked to begin with? Inbox. I don't have anything in the inbox. Continue. Save. Let's go ahead and save really quick. Let's name this Machine Learning 101. Quit to the main menu? No, I don't. Okay, here's our plant. Our required purchase, apparently. Errors in the database. Okay, let's get started here. Spanish school. Still Spanish school. Errors in the database. Hello, we have some errors in our questionnaires data. We can't solve the problem by ourselves. Can you please fix it? I wish jobs came to me like this. Jobs would be so much easier to do if they actually came to me like this. Or at least have something to do. Of medals. Your efficiency is measured not just in money, but with medals also. Medals influence your story progression while boosting your self-esteem at the same time. Oh yes, yes it does. To get a medal, your scheme has to meet respective time and node limits. You can improve your result later on. Okay, so I guess it is the efficiency part of the game. This node destroys elements. Important detail. No matter how many trash cans you have, they will count for one node in the node's limit. Okay. That's good to know. In the real world, real datasets have a lot of errors. Filtering out errors is a very important skill for all data scientists. And we have an article here. Learn how it works. Warning, maths, integrals, derivatives, and scientific words inside. Let me just check really quick. There's some good resources here, it seems, or at least so far. Enough to get you started. Let's see. I'm going to post the link for this one in chat in case anyone wants to click on it. So this is data cleaning. We'll call it. So this is data cleaning. If anyone wants to take a look at that, that's what it is. All right. All right, so we have red, green, and blue. We don't want blue. So we're gonna need to get a trash can over here. What's... So if... Okay, so this is else. Wait, hold on. How can I remove this? How do I remove it? Okay, I just do it like that. Okay, so this is if, this is else. If blue, go this way. Else, go this way. I think that's what it means. Alright, let's test that out and see if it works the way I think it does. Yes, it does. Very nice. And I guess we can speed it up here if we want to. But I just kind of like watching the little boxes keep going. Keep moving the boxes. Time spent 28 seconds to process. Nodes used too, okay. And there goes the cut to cat cloud again. Errors in the database, number 2. Spanish school again, okay. Hello, it's us again. We found some new types of errors made by our users. Please update your program. It will be easier if you use the previous version of the code. Yeah. Can't ever predict what the users will do, so it's up to us to fix them. Deep news, non-neural artificial intelligence. Every day since 1905. Wow. Seems like programming has existed since at least 1905. Hello, I am Eliza. Hi, Eliza. How are you today? What would you like to discuss? Mankind has always been trying to create an artificial intelligence. Before the invention of neural networks, people used expert systems. An expert system is a deterministic algorithm which reproduces decisions of a real person. Okay. All right. I think I got. Okay. I kind of get that. An example is Eliza, the very first chatbot in the world. It's created in 1966 and talked with the patient using questions similar to real psychotherapists. It worked horribly, just like the robot calls that you run into whenever you're trying to get help on the phone. Oh my gosh, too real. But then again, this kind of reflects reality without actually getting into the nitty gritty of the code. If you ever used MATLabs or are familiar with MATLabs, it's kind of similar, I think. I've only used MATLabs once back in college when I was doing a research thing. Basically, I had to connect instruments through a computer and control things from the computer to do things. Lots of things. It was a pain in the butt. I had no idea what I was doing. I knew some programming at that point, but I had no idea how to work with MATLAB. It was horrible and no one taught me how. I had to figure everything out by myself. And Google really was not a thing you used back in the day or could use back in the day to help with that. You needed manuals, and manuals I did not have. Custom nodes are special nodes containing your previously designed schemes. Press on the middle tab to switch to custom nodes. This thing. I'm kind of Am I covering it? Yeah, I'm kind of covering it. Let me move it here. Let me move here. I gotta move somewhere. Maybe I could, Nah, we'll keep it. It's not the main thing here. Drag the custom node, sorting the color red to the workspace. If you want to modify the scheme inside the custom node, double click on it or press the down arrow icon. Huh? Huh? So this is the... Huh? There we go. I was wondering what was happening there. Okay, so... if red, go up here. If blue, go down there. Okay. I don't see any issues here. Are we getting greens that we're not supposed to get greens? Or... Well, it seems to be working. It seems to be working. I don't know what the issue is. Let's see, errors in the database. Okay, let's try this again. So it was the without blue, I think. Okay, let's go back to the email. What was the actual question about? Previous version of the code, errors in database. Private history of expert systems. 1965 can be considered a starting point for the work on creating expert systems. That year, scientists of Stanford Research Institute, Edward Finkenbaum and Bruce Buchanan, teamed up with Nobel laureate Joshua Lederberg and began working on a computer system designed to determine the molecular structure of chemical compounds. I guess that's the start of it. Errors in database, okay. But which one did you want me to work on? Because, as far as I could tell, this one works just fine. This one works just fine. And this one works just fine. So what is wrong with this? Oh wait. If blue. Okay, no, everything seems to be working just fine. So speed this up a little bit since we already saw this one. Okay. I don't see any issues. Well, let's try something else here. So if red, go over here. Otherwise, trash it. All right, start that. In this task, you need to use one of your previous schemes. Fine, fine. Only red, only red. So we want only red. Okay. In this case, where's my trash can? I guess I don't have a trash can. Errors in database 2. Which one do you want me to use? Is it this one? Is it this one? Because I think this works just fine. Okay, that one works just fine. I'm pretty sure this works just fine also. Unless... Okay. I'm gonna have to go back into my emails and figure out which one they actually want me to do, because it's a little confusing. So this is the one I did, without blue. And then they want me to do only red. Okay. What if we disconnected that? Will this work? In this task, all sockets with incoming and outgoing data must be connected. Okay. Too many nodes. Hey Doobie, welcome to the stream. And yes, I am a nerd. Nothing wrong with that. Except I don't know what they want me to do. That is the issue right now. That is the issue right now. Okay. Alright, so we have to go and use a previous one. Hey Cam KS guy, welcome to the stream. Alright. So basically we're getting some... So let me just catch you up here for anyone just joining the stream. This game is basically machine learning made easy. It basically teaches you concepts in machine learning without getting to the nitty-gritty of programming. But right now, I am trying to figure out a job they want me to do. And I don't know how they want me to do it. That is the problem that I am running into. Let me just exit back here. But there's actual facts in the game that tells you certain things. Okay, so our job is we found some new types of errors made by our users. Please update your program. It'll be easier if you use previous version of your code. So our previous code was this one, I think, where you sort out these color blocks into these two nodes. If it's blue, we want to send it to the trash can, and if it's anything else, we send it over here to the output stream, which is where we want it to go. That is our previous code. Now here's the issue. They say use your previous code, and that was our previous code. I think it was without blue, this one. And it works just fine, but I don't know what they want me to do. I think they want me to do a only red, which this is kind of, I think this one only does red. Hey, I did use a previous build of my thing. Unless, okay. Let me try something else. Let me try something else. It's confusing how they want me to do this. Unless this is what you mean. Unless this is what you mean. If red, else, so if red, it goes up here, else trash it. I think trash it. Yeah, only red goes up here. Everything else goes down here. But this is so inefficient. I don't think I would do it that way. Well, I think that was a concept as far as using previously made builds and connecting them this way. So it's a little bit confusing when you do it in this sense, because there's no reason to use... Okay, so let's think of these as functions. If you know what a function in... So let me just go over what a function is in programming really quick. So a function is just a small set of code that does a specific job. In this case, we have a function called red else divide. So if it's red, we send it out somewhere else. We send it and process it somewhere. In this case, our output stream over here. But why would you do it this way? I wouldn't do it this way. This is too inefficient in my view. But I think what it's trying to say is you used as little nodes as possible, and this is the result. I think that's what it's trying to say. Okay, we did what I wanted, and now we paid 62 cat bucks to the cloud because we gotta upkeep those server costs. Eliza, world's first chatbot. So cute. Of course. Okay. So I guess we do this one first before we can do any side quests. Though, as I mentioned earlier, I'm not really gonna do side quests unless we have to, because that would just make it take a little bit longer. Cat overflow. Hey, is there any way to detect a cat without using expert systems? It works for text, but with pictures, not so much. Furthermore, that cat won't sit still. That it does not. Try decision trees then. Those are like expert systems, but on steroids. Once you feel comfortable around them, try Sift. This little devil is way more effective with pictures. Also works nicely when paired with other algorithms. Or you can use nails or glue or something. Come on, it's just a cat. It won't fight you back. I'm joking, please. Just don't use anything I mentioned on an actual cat. I had to think about what IJK meant. I don't think I've seen it that way before. Different nodes have different processing rates. This parameter will influence the efficiency of your schemes. Icons on the right indicate amount of time required for a node to process one element of data. 0.3 seconds is much faster. This node compares output parameters, the sockets, with an element's color. If the element color is equal to only one socket's color, the element moves to that socket. Okay. Element's color satisfies both conditions or none of them, it goes to a random socket. Decision tree is one of the basic machine learning algorithms. Each tree knows a limited number of classes. For each element, the tree asks some questions and chooses the class most similar to the element. And then it does give you resources for videos and articles that show them. So definitely some personal research if you're interested in that. Okay, so we can only use one node here, and we got to do it in 14 seconds. So we're not going to be using this expert system because that takes way too long. So instead, we're going to be doing the decision tree. So if it is red, goes up here. If it is blue, goes up here. And then green, since we can't sort green out, it'll just sort it out randomly between the two. All right, let's give this a test run. I'm gonna slow it down a little bit. It's because I kind of went by too fast. So that took about 11.5 seconds out of 14 maximum. Nice. It worked well. You know what, just for funsies, I'm gonna go and check these side quests. Anything on this vertical axis is a main quest. The ones on the side are side quests. Basic machine learning is in green. And then almost machine learning is in purple, whatever that means. All right, let's give this one a try and see what this gets. This is from Medics at cat.meow. Medics. Greetings, our company is manufacturing all organic natural painkillers, which means nothing. They are used to decrease suffering, mood improvement, and coping with eating disorders. Known side effects, including dilated pupils, diarrhea, physical and mental addiction, are caused by the human factor from time to time. From time to time, our workers pick the wrong plants because they look like medical herbs. We'd like you to design an algorithm that would sort herbs by petal colors. These medics people seem very trustworthy with their all-natural painkillers. Oh my gosh. Oh well, a job's a job. We don't ask the client anything about this. To decrease and increase speed, click button. Yes, I've done that before. I'm just gonna do it times 2 would be good enough. All right, so we have. So red goes up here, blue goes down here. We can use 3 nodes. So I can either use a decision tree color or expert system. Let's try to use this then. We don't need any trash stuff. But I do need to probably... Okay, let's try this. We're going to connect this one, the main cargo data, to this first decision tree. Whenever we see a red, we have 2 things here that have reds, and all of them have green. So if we see a red, we will send that to this decision tree color because it goes fast. And if we see blue, we'll just send it straight to this output stream over here because it's the only one that has blue. Now, if we see red again, we'll send it up here and we'll send it down here. So for this one, we'll make a decision tree for both red or red, which doesn't make sense at the end of the day. Like this, if you asked me to do something like this kind of seems funky. But at the end of the day, green will go through any of these 3 really, really fast. And that's what we want. So let's give it a test run and see what happens. So green is going all over the place, which is what we want. And red is going top and bottom only. And blue is going this way. So these 2 data pools are done quite fast, and we didn't have to use more than 2 nodes. And it went by really quickly. Yeah, so this is more of a logic game, but it does teach you some concepts. If you got any questions for me regarding programming in general, let me know. I don't know. I can't answer every single question because I know just a few things about programming. My background in programming is I've done web development from scratch. I have done some Python scripts from scratch that needed to, well, Python scripts are always from scratch. Python scripts that the specific functions for actual laboratory work. But machine learning itself, I am a noob, very much a noob. So we're kind of learning some concepts together. So it's kind of basic machine learning is what that one was. You know, those go pretty fast. Let's go check this optimization thing out really quick. From the Spanish school again. Optimization of the code. Hi, it's us again. We hope it's our last request for you. We've changed our database system. Can you update your code one last time? We need to work faster. Always gotta work faster. Alright, so in this case, we just want red to go over here. I think that's fairly straightforward. But if we use this, it's going to be really slow, I think. So what we can probably do well, let me just check something. If this processes data in about 0.6 seconds. This does it in 1 whole second. This is more accurate, but it's also slower. So let's try to connect this here. So we're processing all colors and into here. If it's red, we send it over here. If it's blue, we can't. If I do this though, it's going to be. All right, let's not use those. May have to use one of our previous things here. If red, else divide. We'll probably use a previous program that we had. Send that here. I don't know how long this actually takes. Oh, it's using an expert system. That would actually make it take longer. Well, let's just see it. Let's just check this out and see if it goes any faster. I'm hoping this doesn't take more than 18 seconds, but we'll find out. And the clock is ticking, and this is processing very, very slowly. Stop it, because that is taking way too long. We don't want that. Okay. Maybe I have to start that one over again. Unless they gave us extra time. Alright, let's just do something really simply. Let's try to use a decision tree over here. Process it there. Process it here. If it's red, it will only go here. But if we get a green, that's going to cause some errors, and that is not good. Thing is, we have to connect this. We must connect that. Yeah. It gets clogged up if we don't connect it. Alright, there's gotta be a way to do this really simply. See, what's this do? So if blue, it goes down there. Else goes here. Well, let's just see really quickly what this does, because this is the most straightforward thing to work. If it's red, it only goes there. Otherwise, we trash it. That's the most straightforward processing. But apparently it's too slow for our system, and they don't like that. They do not like that. Okay, so. Let's try one more time. Try one more time. I don't want to spend too much time on a side quest because we got to keep the story moving here. Keep the story moving. But let's see what we have. This one. Okay, there's got to be a way to use these decision tree things without having to... Okay, so if any... Oh, that's going to be messy. I feel like that's going to be messy. Alright, so red, we want to connect over here. If it is... Oh, I think they did mention if it is... If you use a trash can, that only counts as one node against you. So I guess that's not a bad thing. Alright, so let's try that then. We'll connect it here. This is probably the fastest processing that we'll ever do. So blue will always go down here. And then if we find any stray greens, they're going to go down over here. I think this is what they want us to do. Now, is this the fastest processing? Yes, it is. Good. We can release that. I was overthinking it. Overthinking that problem. All right. Almost machine learning this thing. All right, back to the main story. Hey, Yanfly, welcome to the stream. So, I was mentioning earlier, this does not get into the nitty-gritty of actual programming. It is more of a, what do you call this? If you ever use MATLAB, if you're familiar with MATLAB is, basically it's a bunch of user interface components. Okay, big words. Small words. Let's use small words this time. It is basically a bunch of pictures that you drag around the screen and connect via wires to do certain things. That's the simple way I can explain what MATLAB is. And those wires connect to a actual thing. So let's say you connect a let's use something simpler. I was gonna say some specific laboratory instrument, but that might be a little bit too jargony. So let's just say we decided to attach a toaster to your PC for whatever reason. We decided to attach a toaster to your PC and used a program to make that toaster get to a certain temperature and only that temperature. And once it gets to that temperature, we hold it for a certain amount of time before we pop whatever you put in the toaster. That's kind of how MATLAB is. You connect the toaster to your PC, and then from the PC, you control how the toaster works. There we go. I think that's the simplest way I can explain that. This is basically the same thing, except it's all in here. We're not connecting any peripherals to the game. Let me see what this one is. Who invented decision trees? And these are the actual facts here in the private emails, by the way. Random machine learning facts like cat.meow. Who invented decision trees? Decision tree is one of the automatic data analysis methods. The first ideas of creating decision trees date back to the works of Hovland and Hunt in the late 50s and 20th century. However, the fundamental work that gave impetus to the development of this direction was a book named Hunt, Marin, and Stone Experiments in Induction, published in 1966, and this is a real thing. Now, I have not read this book, but the concepts are there if you want to check that out. So, all right, let's actually check this email out and see what we got. Good day. I study ancient manuscripts and books in order to figure out the true story behind the Illuminati secret society. Oh no, we got a nut job case. I need to recognize all the triangular shapes in these documents to solve the puzzle. Can you design a program that would do that for me? From Strange Man. Just a hint for any freelancers out there, do not pick up strange emails and do jobs that might, I don't know, upset the world balance or something. But in this game, we don't care. We just want money for things. Yes. So let's do that. In the game, Sift. This node compares shapes of an element. This node compares shapes. If an element shape matches the designated shape, said element goes to the top socket. If else, others go to the bottom socket. And it takes 1.25 seconds to do that sorting. Scale invariant feature trans. Okay, what? What? I don't understand this term. What? Scale invariant feature transform. Let's try to break that down. Scale invariant. It doesn't, okay, from what I'm understanding, it doesn't care what you put in, but it will sort it out when what goes out of it is what I am understanding. So, Yanfly, you're the programming expert here. Tell me if I got that right, please. In one of the most powerful non-neural algorithms for detecting features on pictures. Ah, I see. So this is what they use for image detection, for facial recognition in images. That's interesting, actually. That's actually really interesting. Which is essential for image recognition. SIFT is very fast and capable of recognizing simple objects and patterns. Article and video. We will not go through that. All right, let's get the SIFT thing over here. We only want triangles, apparently. So let's change this sorter to a triangle. Connect that over here. And here is our data pool. We have 21 of everything except for the triangle. We got 42, the answer to everything. Oh, we don't want this one. We want the trash can. Everything else we are going to send to the trash can because we don't care about it. All right, let's run that. Okay, so all the triangles are going to our output node over here. So far, we've learned a bunch of sorting through this game. Nothing too deep just yet, which is a good thing because I'm not sure if we're ready for anything too complicated. Well, that succeeded, and Cat Cloud always gets its cut of however much it is. Working for the man feels too easy. Boring or soul-sucking. Aim for the sky and become the CTO of a startup. In the world of savage market laws, it's either sink or swim. Will you get rich or bite the dust? It's worth trying anyway. I guess we're going to be working on actual companies soon. So task type, neural networks, basic machine learning, almost machine learning. We're not going to do the side quests for now. We're just going to keep going. It looks like we're going to be doing a video reel next. But there's a few things that popped up in CB. 40,000 cat bucks for a Banhammer miniature? What the heck? Come on. I know it's a popular series, but it doesn't have to be. It doesn't have to be that expensive. What the heck? Cactus protects from radiation. Okay, we don't have any new... Oh, we do have new hardware. Increases sockets processing queue by 3. Rentium. Increases node work speed by 1%. Transfer data speed by 1%. Tambourine increases... Is this a tambourine as an actual instrument tambourine, or is this an actual tambourine as in something that I don't know what part it is tambourine? Nodes, we don't have any new nodes. Cats. 3,000 cat backs for a Viking helmet for the cat. Cyborg cat is 5,000, we only have 5,000. Sockets processing queue by 3. You know what, I think I'm just gonna go buy all these hardware. It might help. And the cactus, because radiation is bad and we need radiation protection over here. It's an actual tambourine. Hmm? Why does the tambourine shoot lasers? Here's our cat. Here's the cat that solved our programming problem at the beginning of the game. Alright, let's keep going. Okay, I did not get a job. A letter from mom and dad. Oh, this is different. Mammy, dad. Looks like they share an account. Okay. Letter from mom and dad. Hello, dear. We remember how you cherish your financial independence, but come on. Your birthday is just around the corner. Be a good kid and take this money and buy yourself something nice. We love you very much and we miss you. P.S. Do not forget to put a hat on. It's very cold outside. But, Mom, I work inside. Thank you, Mom. We'll take the money. Thank you. Alright. Where's our jobs? Where's our jobs? Job? Startup? Nope. How do I get to job? Let me save first. It's been a while. Okay, how do I get to job? I just went to CBay and lost my jobs somehow. Oh, this is our computer. Can we check out what's in the tower? No, we cannot. Oh, the tree. That's where jobs are. Okay. You have reached the end of the epoch. Click one of the banners to proceed further in the story. Bronze, silver, gold. I wonder if this is difficulty. Which one looks good, guys? Which one looks good? Seems like, so we do filmmaker stuff if we do bronze. Unless this is just a banner. Gold? Let's go for gold? Okay, let's go for the gold. How hard can it actually be, right? Eliza, first chatbot. Cat's biology, iRobot. Silver looks raddest. I'm sorry, we already took gold. Cat mail. Hey, it's Young Cat. Is Young Cat copyright or is that public domain by now? I wonder. But we got mail from Young Cat. And oh, click. Okay, so we got an old TV, an old camera that somehow we're able to hook up to our computer. Okay. This definitely should work. Cat doesn't think so. Look at Cat over here. He's like, really? I don't know about that, dude. Eureka! Oh, Cat is captured on camera. Meow. Eliza, what happened? Meow. Yes, meow. Repeat, please. Meow. The cat has been detected. Okay, but Eliza cannot understand what Cat is saying just yet. That's a cutscene. I see. Alright. Rosenblatt perception. I do not know what this is. So we searched animal emotions recognition and cat overflow. Okay. If you stick around with me, we'll get you that brain power. But you gotta ask questions. Otherwise, I don't know how to explain things. I don't know how to explain things without being asked questions. So I managed to make my computer detect the cat, but that beast is a complicated soul. It definitely has more to tell. Maybe it's time to go to the next level and start recognizing emotions. Cat emotions. I don't know about that. For anyone that has pets, can you tell what emotion your pets have? Like a cat or a dog? I know rabbits are a little bit stone-faced. Dogs are easy to read. Cats, though, they just look grumpy half the time. They do. Ever heard of perceptrons? They were invented in the 60s to recognize written text. Everyone knows that everything invented in the 60s is awesome by default. The double helix, rock and roll, lava lamps, Linux. That's why we can't get rid of Linux. Oh my gosh, Linux. Was Linux in the 60s or 70s? I keep forgetting. You can also maybe switch to dogs instead of cats. Decision trees work like magic for my Pluto. You can also hit the store and get that random forest node. A forest is more effective than just one tree, you know. Dog days. Oh, okay, we see what they're doing. Error rate, and now for something completely different. Perceptrons can actually learn and improve. Okay, so part of machine learning is actually improving the AI. So when you do machine learning, you're actually making an AI that learns over time. That's what machine learning is in essence. And I guess in this case, we are trying to make the error rate of the machine or program we're creating so that it's less prone to making errors. Like, you know, Google Translate, supposedly there's machine learning in there, but I don't think there actually is. It seems to be mostly user input, from what I could tell. And users are the worst at trying to teach a machine how to learn. And now for something completely different. Bad news, they also make a lot of errors on the way. Percentage of the errors is shown in this icon. I see it. Use training mode to teach perceptrons and decrease the amount of errors. So this is actually one of the first lessons you get in machine learning, not all the if-else stuff that we did earlier. That is basic programming. This one is where we actually start doing actual machine learning, lessons. Training mode, perceptrons reduce the amount of errors while trying to predict shapes of elements. In test run, perceptrons only predict shapes. In test run. But we gotta train it first. Rosenblatt's perceptrons used in Mark 1. This perceptron could recognize only simple linear dependencies. I don't know what that is. But it was enough to recognize English letters. I guess that's a start. It's a start. Alright, so we have a perceptron here. Looks like we have 3 nodes that we can connect. So, yep. Circle goes to circle, square goes to square, triangle goes to triangle. And we enter it into here. We gotta train this thing first to get it to 100%, otherwise it's gonna cause errors and it's gonna actually probably send a square into circle, a triangle into circle, and a square into triangle, that sort of thing. So let's train it first until it gets to 100%. Oh, this is the error rate, never mind. So we need to get the error rate down to 0. And that's gonna take a little time. The nodes on the field have reached their minimum margin of error. Okay, there's nothing more you can teach it. Okay, so I guess it never gets to 0% error rate. Now I'm trying to think in real life. I've only done maybe like 1 or 2 basic machine learning things where you teach the program to like to do things. As far as sorting, which is like the basis of machine learning, it sorts input, like whatever you give it, and hopefully it gives you the right answer. But in this case, I could have sworn that the minimum margin of error is supposed to be something like 3 or 5%. I don't know if that's something that came up from the top of my head, but I would have liked it to at least be somewhere around at least 5%. 5 to 2% would, but if you're doing something like self-driving cars, which I think is partly machine learning and part GPS, you definitely want that to get as close to 100% as possible. 20% would be unacceptable. They would crash all the time. All the time. Alright, let's do a test run and see how well this actually does. So circles are going to where they need to be, triangles and squares are going where they need to be. But once in a while, it's sending a wrong shape. So I feel like there's some RNG to this mission. That's why they gave us enough time to do that. Okay, so yep, self-driving car. This is what I was talking about. Let's go to text recognition first. Actually, no, let's do the easier one, almost machine learning, and then we'll go to neural networks for text recognition. Let's see, goal, learn how to detect cat in pictures. That's done. Perceptrons, good for pictures. Grandpa probably used it. Probably. This is decision tree equals smart tree. It's the smartest tree. Okay, so I think side quests are just mainly for cash, but we're gonna ignore those for the most part, unless we run out of stuff to do. We'll probably, if we get through this quick enough, then I'll probably do side quests in another stream. I'm going to be doing this for a while today, so this is not going to be a short stream. We're going to get our thinking brain, we're going to get our thinking caps on. We're going to do this one first, though. Notacat@meow.com. Reinforcement learning, RL. Oh, RL is reinforcement learning, gotcha. Hello. Okay, this 200 cat bucks and a very badly written email by a cat. Hello, we is a society of peoples who love cats. We want our cats to has all the best. We want cats to drive cars with no human inside. But cats have no hands, cats has paws. Can you make a car that self-drive? Yours, Dr. Meow, is cat, human person. Please excuse our grammar. We are not cats, we are humans, but we can't type well because we has paws and no hands. Terrible car accident, bad surgery is why we need self-driving cars. Okay, let's take a job from a shady cat, not human. Human, not cat. Reinforcement learning tasks nodes work in a bit different way. All data is initially unspecified, and your task is to recognize it and transmit it to RL agent, the AI. Gets the unrecognized data. Okay, so we won't know what it is until it goes in. Not that we care, because at the end of the day, you don't really care what you put into the program. If it's not something you need, it goes into the trash. Otherwise, if it's something you need, that needs to get sorted out and processed. Classifies as object or road. Objects go to the upper socket, roads go to the bottom. SIFT is one of the most powerful non-neural algorithms for detecting features. Okay, we already did that. So this is another SIFT thing, another SIFT node. All right, so put this in here. Okay, so this one only gives car and road. And I guess we put both into here. Let's do a tuning first. Training model. On this screen, you'll be training and testing your AI. AI acts based on data you've been recognizing when building your scheme. I don't know if that's proper grammar. The data about surroundings on the road are processed from your scheme to machine learning model. Your car won't be capable of learning and detecting obstacles without it. Yep, this is what they gotta do for self-driving cars, which everyone wants because no one really wants to drive. But to get there needs to be a camera on the car, as well as hopefully some sound receptors, or maybe Doppler guns or something like that. Something that detects what's around the car. That's a lot of data to process, and I think this is kind of what it's mimicking. Goal in this type of task is to make the AI clever enough to be able to reach a target average speed level. So they're probably going to be driving slower than your typical human, for safety reasons. Press supervised learning and drive the track yourself using arrow keys, or it's to teach the AI. Be careful, the car sees only objects inside a green area. LiDAR area, the green. Supervised learning. Okay. Okay, wait. Where am I? Which one am I? Ah, this is the car. I see. Okay, hold on. We're gonna train the AI again because this is okay. So input the environment is going into the processor. I don't know what these exclamation points are. So whenever it says epoch number, this means the number of tests that you've done for the AI. The higher the epoch number, the smarter, the more clever your machine is, your AI is. You want that to get as high as possible to where it doesn't crash. I think there was a simulation in YouTube that I saw, a video that I saw where it kind of demonstrates machine learning, and there's like a track, a curved track. I don't remember why I saw it, but it basically took, I think, over 200 crashed cars before one car actually got through the track safely. So you can just imagine how that would actually work in real life. Like very... You've reached the epoch's limit, but your model isn't good enough yet. Epoch limit has been reset. Try using other parameters. Okay, let's do supervised learning again. Okay, so we're gonna try to avoid car. So whenever we see a car, okay, so road, it's getting road, but we don't have enough space here. So if we get car this close, we go ahead and shift over. And still recording down here, so we'll give as much data as it needs. And we're driving at 51 miles per hour, which is about 30, let's say roughly 30 kilometers per hour. Okay, so training I think is done. Let's save that. So launch training, and then we're going to test. Let's give this test. So right now it is sorting data. It is currently evaluating the AI. And the AI is driving the car, keeping a safe distance. It hasn't crashed yet. But it hasn't moved either. So it's definitely not trying to overtake anything. It's just keeping behind the car in front of it, which I think is the safest thing to do, instead of driving aggressively and trying to get in front. Let's keep going in evaluation. Almost done. Oh, what's that 0.5? Let's go times 2. Go a little faster. No wonder it was so slow. Average speed 50 miles per hour. AI costs 203 cats. Server cost, okay. Launch is failed. Why? Why is the launch failed? Okay, I can't sift that. Why is the launch failed? Microseconds. Well, it has to be pretty fast, doesn't it? Okay, let's sort this out first. Let's do a test run. Okay. And then let's do some tuning again just to make sure. Do some testing just to make sure this works properly. Your model has achieved target speed level. Good. Okay, let's try this again. So in the environment, all it sees is road. And it's going a little bit faster now since it doesn't see anything in front of it. It's keeping at speed, going a little faster. There's no car in front of it. Launch complete. You know, that's kind of... this one's a little bit... this test is a little bit iffy, but... It takes a lot of money to develop the AI to make sure it's safe. That's probably why it cost 519, and we're only getting paid 200 for this, so this is a net loss for us, I think. Unless the reward is 519. Never mind. All right, let's go back to this other one, the actual machine learning thing. But that's also actual kind of sort of machine learning. ReCAPTCHA company. Okay, so this is for CAPTCHAs. The images that ask you, are you a robot, or pick which ones only have bikes, which one only have stoplights, those kind of things. Text recognition. Also the text that half the people can't read, myself included. We are aware that you are able to create a text recognition system based on the Rosenblatt perceptron. We need a similar system that would also be able to distinguish vowels from consonants. This test is simpler, but more accuracy is required. If you think about it, how do we decide which ones are vowels and consonants? You know, your consonants are A, E, I, O, U, and never Y. Don't ever let anyone say Y is also a consonant, because it is not. So how do we decide that? We're taught that. But do we accept it as fact? What is the definition of a consonant? How does a definition of a consonant get how was that definition created? I guess that's a easier way to say it. So you have to go through that thought process also and teach that same thought process to the machine. Now, in programming terms, it's probably easier to just give it an array of what all the consonants are, an array of all the characters, and call it a day. But if you're not doing that, there might be a different way to do it. We'll see. I would have used an array, but for shapes we don't have that kind of luxury. Deep news: Rosenblatt perception. First perceptron machine neuron was invented by Rosenblatt in 1957. Oh, so we're actually using the same things, like squares, triangles, and circles. Frank created Mark I in 1960. Mark I is a perceptron machine that can recognize English letters by their shapes. I wouldn't have thought that. I would have not thought to do it that way, but I guess if you're doing it from an image and not a text file, it would make sense to go by their shapes. And if you kind of think about it, vowels tend to have a very compact shape. And so if you look at these, A, E, I, O, U, versus everything else. So you might be able to mistake a B, C, D, F, L, M, N for not vowel, especially the C, because if you look at that just by shape alone, it kind of looks like a O, right? But it's an open O, and the machine would have to figure out how to differentiate that from C to O. I don't know. We're just going through thought processes here. I'm not explaining anything in deep, but that's a thought process, right? Okay, so let's get this sifter here, mark perceptron. All right, so if it is a circle, go up there. If it is a square, go down here. But what do we do with the triangle? It can go either up here or down here. Well, I guess we'll send it to one or the other. This one needs less samples. So if a triangle makes it up here, then I think we'll be fine randomly. But we're gonna need to send most of it down here because this is where we need most of it to begin with. Let's see, what's the thing here? Alright, that's just the facts. Alright, let's train it first, get the error rate down. So there's a couple of triangles that do make it up top, also a few squares because of errors. But it seems like most of the triangles do make their way to the bottom node. That's a good sign. So we got our 20% error rate and then our threshold of 75% for both of them. Let's go ahead and actually do the test run. So this one is filling up faster than the top one because we are sending both squares and triangles down here because we do want it to fill up faster. However, the top one is filling up slower because there's not as much circles making their way through, it seems. Accuracy is 94% for the top one, 87% for the bottom one. Not great, but a good start. Not great, but it's a good start. Alright, we'll take it. Alright, I'm kind of curious about the self-driving car side quest, so let's go ahead and try that also. One does not simply walk into Silicon Valley. Complete the tutorial startup Mama Smith's Pizza Shack to gain access to others. Mama Smith's Pizza Shop. Which one's that? Oh, okay. I see. Alright, let's go do this one then. Pizza Smith at Cat.meow. Hello, we're honored to invite you to join our startup, world's first AI-controlled pizza place. No humans involved. Imagine a robot making your pizza. I think they can do it. How hard can it be, right? You just mix the dough, let it sit for a while, and once that timer has finished, portion a piece of that dough out, roll it out for pizza, and then you have a dispenser for sauce and cheese and whatever toppings that you want for that pizza. And if there's an oven, send that to the oven, bake it for however long it needs to be. Take it out after a certain amount of time and package it. However, whether or not the pizza is actually going to come out right, that's for people down the line to test. And whether or not that actually comes out right, well, there's some quality control that needs to be done there. So, all right, we're honored to invite you to our startup. Okay, I read that part. But our fingers are always stained with flour and we can't really code because of that. Shame. Help us write and implement an algorithm that will be capable to separate orders for round pizza from orders for square-shaped pizza. Let's feed the people and become rich. Let's do that. Scheme created while working for a startup does not differ from any other, but there is no solution to startups. A scheme just works better or worse, and your future profits depend on its quality. So round boxes, square boxes. Square pizzas. Okay. Well, this is fairly simple. Fairly simple side quest. Seems to be a tutorial side quest. There's only 4 pizzas here. And this is a basic if-else statement. If it's square, go down. If it's circle, go up. Further testing won't affect the results of startup. Okay. Trying to design an AI-controlled pizza place. It serves pizza in round and square shapes. And there's some pepperoni. I see some sausages, bell peppers, cheese, and there's one pizza with egg and salami and pepperoni. Egg on a pizza, well, there are breakfast pizzas, but some people might take offense to that. I see some olives over here. Nice. But yeah, these are robots making your pizza. Probably in the future. Soon to come. Scheme of design is the brain of the pizza robot. It sorts orders by the shape of the pizza in client's orders. So this one is sorting, this one is also sorting. These are the users of your startup. In this case, your pizza restaurant. They've heard of the amazing place in town and now they want to grab a slice. These are your client's orders. The millennials don't care too much about toppings. Only shape matters. Some millennials these are. Come on, you gotta have more sense than that. And taste. Mind the accuracy. If a client gets a pizza they've ordered, they will pay you money and tell their friends about the place. If a client doesn't get what they want, they refuse to pay and don't expect them to return with friends. One more thing, clients don't like waiting in queues and will leave with no hesitation. No one likes to wait, apparently. If your scheme is working slowly, the waiting line will get longer. Well, tell that to the ramen shops. The ramen shops have 2-hour lines, sometimes 4-hour lines, and people will wait for them. They're just that good. The market is constantly changing, so pay attention to what's going on and experiment with your schemes. And now it's time to launch your first startup. Okay, let's release it. Okay, let's release this one. Hype. We got hype. Press next day to proceed. This table is your principal source of information about startups. Income. When you switch to the next day, you get money you've earned or lost, depending on how many users' requests were processed by your scheme. Next day to proceed. Reward. 1,000 cat bucks, but the cloud uses up so much of our pay that we did not get much out of it. Hey, look, your users seem to like what your scheme is doing. They've been inviting their friends. Cash is flowing. When hype icon is green, that means your startup is all over the news. Expect lots of new users. Okay, so I guess we got this going on the side. Doesn't seem to be anything that we can do to improve this just yet. It's fairly simple. So we'll just be getting passive income this way. Though I don't know why you would keep pressing the next button unless you just want extra cash as we keep doing this. Alright, what do we have? Fade in cut. Brush your hair with your hand for perfect style, but why does that cost 500 cat bucks? Backdropaganda poster. Data scientists of the world unite. Sure, but let me see if there's anything useful that we can buy. Hardware? No good hardware. WTLVR increases respect from the developers. Just for having a VR set. That's respect. All right. I like this poster, so we'll go and buy the poster. And we have the poster that's not really visible in the back. Then what good was the poster? Time is passing and the market changes. When hype icon is yellow, it means that your target audience is already aware of your startup. Don't expect many new users at this point. When hype icon is gray, that means that you've satisfied your target audience. Users starting to leave. Press next day. Watch your earnings carefully. When the number becomes red, it's time to cash out. I see. I see. So we can keep doing this until we want to. Alright, so the number of users are steadily declining. We are getting some cash for doing this. Income is in the red now, so we are going to get out. We are going to sell the startup. We don't need that anymore. And we got lots of cash from it. I guess that's what they do. Okay, it's their problem now. It is their problem. I see how that works. Alright. Okay. There's actually a few interesting side quests here. I do want to do the self-driving car because I just find that interesting. Investment is 4,000 bucks. Okay, that's good. You got some cash to start with. Wyber at Cat.meow. Hi, we are trying to launch our self-driving taxi service. It is a very promising startup, but we have a problem. Our algorithm makes a lot of errors when it tries to recognize traffic lights. As a result, the car sometimes moves instead of stopping. And then who are the cops gonna ticket? I wonder. We hope you can solve this problem. The code must be working very fast. Yeah, sure, let's try it. I am curious about this one. You don't need to train your nodes while working on a startup. They already have the minimum error margin because time is money. Okay, that's good to know. Alright, so let's connect this. Circle will go up here. Square will go up here. And then triangle will only go down here. Let's do a little test run. I wonder if we need to use more than one node to keep the error rate low. That's what I'm thinking. But right now it seems to be working fairly fine, though the triangles are definitely filling up very, very slowly. We may have to use multiple nodes on this one to sort any stray triangles that may come out of this thing, which is not promising, by the way. Okay, so let's disconnect that. Let's get another perceptron over here. Connect these. If any triangles, go here. And if any stray triangles, go here. Again, please. Hopefully 2 is the most we're going to need for this one. Alright, let's do a test run. And we're going to do ×3 because it's going to go fairly slow otherwise. It's definitely sorting the shapes and the upper node fairly efficiently for circles and squares, but the triangles, it's taking a little bit longer to get down there. And we're definitely getting more errors. We're getting less efficiency with this model somehow. Maybe because of the 20% error rate, I don't know. I was hoping that any stray triangles that go into our second node over here would get transferred to the bottom. Which it does whenever they do show up, but it's also sending wrong shapes down here, which is not what we want. And this is actually making things worse. Alright, let's just use one node. Hopefully that's all it needs. Or we may need more perceptrons for later. Let's do one more test and see if this works a little bit better. Thing is, I'm not getting that many triangles to show up. And it's very RNG dependent. Seems to work well enough. But there is definitely RNG in this process. Well, let's try it. Let's see what the result here is. Ooh, it's not always possible to satisfy all your customers in one day. Users with unfulfilled requests are shown in red. You don't have the instruments to solve this problem for this startup, but you will get some to handle the future ones. That is not promising. That just means so it seems like our unsatisfied users roughly reflects the number of the error rate of our system, which is not good. Because if you have roughly a 20% error rate in your system and roughly 20% of your users are unsatisfied, that is not good reviews. That's like, I don't know. So normally, let's say like a 5-star rating, these users will all probably give you a 1-star, 0 if they could, and then the satisfied users will give you a 5-star. So average that down, this is kind of like 2 stars. Creeper World. What is the Creeper World? Yeah, but it's interesting how this kind of mimics actual problems that you run into these kinds of situations. Now here's the thing, it seems like our unsatisfied users are going down lower and lower, so we do have a loyal base as far as the self-driving car is concerned. And now we only have satisfied users. And the income is still good. But we don't have any tools to fix this problem. And now we need to cash out because we don't have the tools anymore. At the end of the day, though, we did get some good cash out of that. I don't think the haircut is worth 500 cat bucks, though. And we don't have the spare cash to pay for anything else. I am curious about this Metal Gear construction, so we gotta get through the dairy products first. Let's try that. Let's do this one. Dairy products manufacturing, but from fresh milk at cat.meow. Hello, my name is Sam. I own a dairy products factory. My dream is to make the very best goods on the market, and that's impossible without high accuracy in fermentation processes. Alright, on the market. Alright, off with the fancy words. I want a program that would judge the quality of a product by its ingredients. What? We often make mistakes when doing it manually, and a lot of our products never leave the factory since we mark them as defective. We have the data, but we need the algorithm. Just by the ingredients? I'm not sure you're gonna do that, but... And they didn't give us much cash to start off with, so... Yeah. And this one's not a startup. So we gotta train this darn thing, and that's gonna cost cash. Okay. Alright, so there's circle in both of them. There might be some stray circles that go down here. So we're going to connect both triangle and square up top. And we're going to connect circle down here because we want circles to mainly go down here. But we'll also accept circles if they go up here. If any stray squares or triangle make it down here, they don't count towards our quota. But let's train it really quick and see if that is actually what's happening. There is some RNG here because of the error rate. Such is teaching. Which seems to be the case. Slow it down just a little bit. So circles are definitely going into the bottom node fairly efficiently. Squares and triangles are making its way up top. I haven't seen any stray shapes just yet, which is a good thing. Though they are inherent in the system. Yep, there was a triangle that was making its way in the bottom. It wouldn't count for anything. Money spent. Alright, let's release this. Okay, that was fairly simple. That was just another sorting problem. Toy manufacturing, though. How did we get from dairy products to Metal Gear construction to toy manufacturing? I am curious about this plot line. I guess we'll make our way down here also for the chicken escape later, because these side plots are interesting to me. Solid construction. Oh my gosh. First, Majima starts a construction company to cover up his shady business deals in the underworld. Now, Solid Snake is also starting a construction company instead of his mercenary corps. Well, I mean, I suppose there's at some point, hopefully at some point, all wars will stop, and Solid Snake will find a way to do something more productive, like construction. Everyone needs construction, and construction will never stop until the world ends. I guess war is the same way, but we would like to hope that it ends someday. Metal Gear Construction Factory. Hello, we are Metal Gear Construction Factory. We produce fittings and supply raw materials to construct grounds all around the world. We are especially proud of our high standards of quality. At the moment, we're receiving a lot of new orders and we are running late with the deadlines. Oh, so you need us to help because of that. An algorithm is required that will analyze the quality of raw material and discard poor quality ore before it leaves the conveyor. Oh, that makes sense. You want to sort the good ore from the bad ore for processing. Manual analysis takes way more time than we can afford. Also, that's the wrong then. That should be THAN, not EN. Jeez. Solid Construct is gaining a lot of liquid finances. Glad to know things are going well for them. Right, as long as Venom Corp doesn't infiltrate and destroy the companies, I think we'll be good. We'll be good with that. Holy crap! Now we have colored shapes. Okay. Okay. This is actually gonna be interesting. All right. I'm gonna try to do this in 2 nodes. Well, we're also gonna need to trash some stuff. Okay, maybe we can... Okay, if you can tell me what Venom Corp actually does, besides underhanded corporate deals, then maybe I'll trust them a little bit, but I don't trust them just quite yet. Alright, so as far as shapes are concerned, we are gonna sort everything through here. So we don't really care what shapes they are. We're only going to do that. Oh wait, maybe we don't want to do shapes first. Never mind. Let's do colors first. We want to do colors. Yeah, because if this is all shapes, that doesn't make sense. Because we take all shapes here, but only certain colors. All right, let's do this. Let's start here. I don't know. The Africa business, doing business in Africa is always kind of shady, if you ask me. Not the Africans themselves, but people coming into Africa. They don't seem to always have the best intentions. All right, so if we get red or... Oh, wait. No, we do want shapes first. Because this if-else statement can only do 2 colors. All right, so... Wait, okay, so for shapes, we want two decision trees. Let's try this. Okay, so for circles, if we get a red circle, this goes here. If we get a blue circle, oh wait, if we get a... Okay, so let me arrange this so it's easier to read. So we want red and we want okay. We want circles we want square and red circles. Square and red. Square and circle that are red. There we go. If we get a blue square or a red square, no, if we get any other colors for this, I think I need to sort by color first here. All right. Okay, let's do this first. If we get red, this goes up here. If we get blue, so if we get any that are not red, or if we get anything else that's not red, then we go down here. Let's go down here. We have 7 nodes to use, so it's telling us it's going to be complicated. If it's green, no, let's do shapes next. Go down here. If it is, then we'll do another color decision tree over here. We already sorted the red here, and we only want red squares or green or red, red squares or red circles. I am getting confused. But I know what I want. I know what I don't want. Okay. If it's red triangles, we don't want it. If it's red circles or red squares, we want it and we want to send them down here. Now hopefully it actually trashes the triangles and works properly. Now for here, anything that's not red, because we don't have any other options, we can only do that. We'll go down here. If it is a circle or a square, we don't want it, we trash that. If it is a triangle, we do want it. And if it is a green, if it is a red triangle, we also trash that, we don't want it. Now, if it's anything other than red, we want that. We want to send it over there. Okay, I think this should work. Let's train it and hopefully it works. Oh my gosh. And we're definitely going to have to do ×3 on this because it is so huge. Okay, is it working properly? No. No, it is not. It is not working properly. Okay, we got more sorting to do. Okay, so we had a bottleneck down here. Let's see. We gotta sort color again first before we do anything else. Otherwise, it's not going to work properly. Okay. And then we can do shapes. So if it's red, we go up here. If it is... where it shouldn't... Okay, we're getting everything that's not red. Go Melem, yes. Okay, so all the red shapes are going up here. We got that going for us. If it is... well, all the red's going up there by default, so I guess we don't need to do that. But we are getting red triangles going up there also. And this is where the problem is. Hopefully you don't get any red down here. Let's try that again. I just want to look at slow motion to see what the heck happened that's clogging it up. Let's train it and let's go slower. Okay, looks like there's some reds going down here because I put any. And I guess it's not an if-else statement. It just says if it's any color, it goes down here, period. Well, that's not how I thought it would work. That's not how I thought it would work. I thought it would... Can I connect more than... No, I can only connect one. So I guess we gotta do shapes first. Let's start with shapes. So to me, it doesn't make sense to start with shapes first. Okay. Let's start with shapes first. So we're gonna get shapes. If it is a red circle or a red square, we want it up here. If it's a square or circle, we want it up here. Otherwise, if it's a triangle, we want it down here. Good. So far, so good. Okay, next. If it's a red square or a red circle, we want it down here. But we will also get stuff that is not red. So we're probably just gonna trash that. Because we can't sort it out any more than this, I don't think so. I think so. Unless we got another color shapes sorter over here, but I think that would take too long. Anyway, so down here we're sorting triangles only. We hope we get triangles only. But it's going to get clogged up if it does anything else. So if it is green or blue, no, if it is a red triangle, we want to trash it. If it is a blue triangle, we send it over here. Can we connect this? Also, no, we can only connect it to one thing. Red goes up here. Hopefully that's priority. I need a splitter. But I can't split this. Maybe I don't have the tools just yet. Thing is, we're also going to get blue. We're also going to get red. So if it's red, we're going to trash it. Anything that's not red, hopefully we get that down here. If it is green or blue, we connect it up here. Hopefully that works. This any clause is iffy because because red also satisfies this condition. And I think I saw it clog up last time too, so that's I don't like that. I don't like that. Well, let's just see how this works. So we're still getting some blues over here. Nodes on the field have reached a minimum. Huh? Did that actually work? Did that actually work? Alright, let's do a test run and see if it actually worked. Okay, so squares and let's go times 1. Maybe times 0.5. Okay, so let me just see. Triangles are going down here. Triangles are also going up here. It's still dumping red circles into here, but that is fine because we got a lot of samples that we can use. Green, so red is still going up here somehow. Oh right. If it's not one or the other, it goes randomly for some reason. Well, let's do times 1. I'm just trying to figure out what's going on here. I don't like this sorter. The sorter is not accurate. Everything else is accurate except for the sorter. I ran out of time. Apparently this takes too much time to sort out. Well, in that case, we are going to leave Metal Gear for another time because I don't think I have the tools for this. I'm not going to worry about that for now because I don't think we have the appropriate nodes to work on that. Random forest node, isolation forest. Are these just schemes? I don't know. Hardware. We will look at that another time. Okay, let's keep going. Parallel calculations. Scientific center. Uh, Parallel calculations. Hello, we represent a scientific center. Our current programs are underperforming. Can you parallelize our calculations? Basically, what they're asking is, can we do more than more than one calculation at the same time? I mean, I guess we can try. It's like multi-track drifting, except this is multi calculations, multi-track calculations, or however you want to say that. To process data, your nodes need computing power, a server. Certain nodes require more than one server. The more servers you use, the more expensive your scheme becomes. So true. In-game, this node routes elements to the least overloaded socket. This node requires additional server power. In the real world, a load balancer is a device that distributes network or application traffic across a cluster of servers. A load balancer. I don't have any experience with this in particular, but I guess what it means is just directing traffic of whatever you send in to the server efficiently. Like, this goes here, this goes there, and we need a set of instructions to do that. Load balancing improves responsiveness, increase the availability of applications. Now, here's an interesting fact. If you don't know, most of the websites you use typically are just one website on a server. Now, that server can host multiple websites. That's probably why something like Cloudflare, which is probably something you've seen before, whenever a site goes down, Cloudflare has run into an issue that one website that you have on Cloudflare that goes down. If something happens to that server, all the other sites on that server also go down, which is a bad thing. Which also, I think they try to prevent that. They usually have backups of that site, so that issue does not happen. At least I would think so, but I don't know for sure. That is my disclaimer. Why do we only have reds? Okay, this looks fairly easy. It's a fairly straightforward thing. It's all reds, and it's just directing traffic, which is kind of what I needed on the other one. Alright. And that was very cheap. Load balancing. Let's keep going. Cat cache miners. Jeez. These miners. I hate miners. Because of all the graphics card inflation and all that stuff. Yeah. Large parallel calculations. Well, I don't dislike them personally. But it's ridiculous. Have you seen some of the mining rigs that people use? It's like rows and rows of graphics cards. There's probably like, some of them have like 10, 30 graphics card on a rack. And a friend showed me how mining works, because they're into it. They like seeing how coins are mined, and they're kind of trying to do it themselves. But it takes so much power. I don't even know if it's worth it. And let's be honest, it's mostly speculative at this point. No one's really using it widely. Now, there's something about some of the major coins like Bitcoin trying to be implemented in daily transactions, but the price of that fluctuates so much. It's a little bit difficult to keep up with. Hey, our parallelization system broke after the last Doors OS upgrade. Oh, Doors. Oh, okay, I get it. This is Windows. Can you fix it? It's a very big system. Be careful. Darkest Years of Machine Learning. In 1969, nice. Seymour Papert and Marvin Lee Minsky. These look like fake names, but these are very real names. If you ever look at scientific papers, they have a bunch of weird last names on those papers. It's like, what? And you know, good for them, but it's like the weirdest last names that you will never see in, almost never see in general society. It's just that's where the weird last names go. They write papers and hold PhDs and all that stuff. In this book, they spoke about math constraints or of the first perceptrons, XOR problem. Not and or? This book has shifted the scientific interest and funds distribution from the US government organization, slowing down the progression of machine learning for almost 30 years. The expanded version of the book was released in 1987, containing chapters that disprove the statements from the critical remarks made since 1969. Say what? Say what? This book has shifted the scientific interest and funds, slowing down progression machine. Okay. Okay, so there was an issue with the first perceptrons, like the Mark 1. Like, it's so inaccurate that it can't really sort very well. I think that's what they're talking about. And because of that, there's been a slowdown, or at least lack of progress in machine learning until very recently. So almost 30 years, so roughly the turn of the millennium. Expanded book, okay. I think that's what it's talking about. Okay, so load balancer over here, load balancer over here. Can we connect? Nope, we can only connect one, so that goes here. And then we'll balance the load this way. I think this is how they want it done, because you can only connect so much, so many servers here. So it sends all that data and then it spreads it out. Yep, I think that's how we wanted it done. Is there anything I can buy here? Hardware-wise. Decrease server cost by 3%. Increase sockets processing queue by 5. Sure, let's do that one. Revise DLL slots? What's a DLL slot? Decreases server cost by 3%. Now let's buy this, let's buy this. It can only help us. Let's buy this, let's buy this. We need to give our cat something, but all this cat skins are way too expensive right now. And our fade haircut is definitely still not something I want to buy, so let's keep going. We'll go back to Metal Gear sometime. Tatari. Dictatorship? Best dictator in the world. Who could this be? Dictatorship. Greetings. This is the only state internet provider of a small country. Dictatorship and monopoly. We have a rather suboptimal code to track our people's activities. Oh my gosh, I think I know who this is. Unfortunately, we cannot allow you to change the actual code, but we have several new servers purchased on a garage sale. Parallel the calculations. This will help our tyranny prosper. Oh my gosh, did they actually make this this joke in here? I mean, I think we can all guess who this is, or at least make a parallel on who this refers to. They shall not be named, but it's a parallel. These are CatHub repositories. CatHub. Well, it makes sense because CatHub is has an Octocat. What do you call his mascot? Look up GitHub. GitHub is a code repository for open source stuff typically, and the logo down here is pretty much the Octocat. Pretty much Octocat. You can choose a version of the scheme which will be used for its custom code. Okay, so we have. It looks all the same to me. It all looks the same to me, so I don't know what's different. Okay, what are we supposed to do? Load balancer. Oh, we only want red. I only want red, so... Only red parallel. Okay, so I think we can... Alright, so we're gonna have to sort it out first. Get it sorted really quickly. And then if it is... And then we need else statements on both sides. If it is red, go here. If it is not red, put it in the trash can. Now, how many servers are we actually going to need? That is the question of the day. But this is a very basic of what we're gonna need to do. Oh, there is... Okay, that's... We need more servers because that is too much for one server to handle, apparently. Okay, so we're gonna need another server over here and another server over here. So sort that. Connect this to another balancer. We're doing some multi-track drifting now. Multi-track processing. It's basically what this is. So if it's red, go up here. But we're also going to need another if-else over here for sorting. So it's going to go down here and then another trash can for everything else that's not red. Good thing trash cans only count as one node up here. Alright, so let's check this out. Everything gets sorted again. There's a little bit of a delay. I hope this is fast enough. It's fast enough. It's not great. But I can't put another balancer in here because that's going to overload the system. This is as good as it's going to get. So we do this number and then it gets stopped here because there's too much data being processed. But this is as good as it's going to get. That's as good as we can do it. And that's the minimum. Cat roasting time. I give it 5 cats. 5 out of 5 cats so far. Wow, 5 cats. Thanks. Maybe you could elaborate on a short review later. I'll do it later. Dictatorship. Let's keep going up here. Prediction of elections. Oh, wait. Is it letting me? I don't think it's letting me... Oh, okay, there it is. Use Control-C to copy, Control-V to paste. Click, hold, drag mouse, select multiple nodes. Program is easy, sometimes at least. Yep, copy-paste. That happens in the real world too. Alright, so what are we doing here? Only R parallel. Alright, so we need balancer here, and another balancer on both sides. I'm not doing the copy-paste thing because I'm also too lazy to copy-paste. And then we do decision tree right here, decision tree over here. I guess we can connect it like this. We should be able to connect it like that. Now, is this going to get overloaded? You bet. It is going to get overloaded as heck. But you know what? I don't know how else to do this. So ideally we want red to go over here, but also if it gets any other color, it will go into the trash can, including red. But primarily we want red on top, on this decision tree. Right, let's give that a try. Yep, and that's pretty much what I expected. Some reds are going down. Now, how fast is this actually going to fill our data? I do not know. It worked with relative success. I think this is good enough. Success, we spent 28 seconds on that out of 40. That is a bronze medal though. Let's see if we can go for the gold at least. Thing is, it's pushing out so much data at one time that it's overloading our system. Maybe we need another balancer here. So this is a funky way to do balancing. I mean, it looks nice, but I'm not sure how well this actually would work. Let's give that a try. Shapes go burr. And we still got red for this because why? Because why? It works. Maybe not efficiently, but it works. Let's try this instead. Let's do maybe another balancer to balance our balancers. And this is a main quest, by the way. Ooh boy. I wonder if I can even use a trash can here. Okay, so decision tree, we don't have much that we can do. There's gonna be so many bugs here. Let's get rid of those. I think this is the best we can do though. Balancer up top, balancer at the bottom. And then maybe another balancer over here. But it's not going to go very well for us otherwise. Because there's going to be a bottleneck once it gets to this point. Red will only go here. Red will only go there. I think I did this earlier. Yeah, there's a bottleneck here, especially with this balancer in the way. 28 seconds. It's connected down here. I don't think that's gonna improve anything. Could try. It looks nice. You gotta say it looks nice, but there is definitely a bottleneck that we're running into. There's gotta be a way to... There's gotta be a way to make this go fast. What is this? DLL is basically a sandbox for schemes. Create them, apply them in tasks, experiment as you wish. You can use almost all kinds of nodes and as many inputs and outputs as you see on the screen. Keep in mind that you only have one slot for DLL nodes by default. Go to the shop to get more. You don't need to train nodes while working on a DLL scheme. What would I use this for? Oh, what would I use this for? Guess we'll get a hint on that some other time. But it seems like we have Oh, it's just an editor. It's a sandbox. It's just a sandbox. All right. For anyone that would like to try to solve this puzzle with me, how do we make this go faster? We have 17 seconds that we need to process all the data in, and we're getting it in 28. This is going to be very brain intensive. But you know what? Give it a try. Give it a try. You might find it, what do you call it? You might find it easier than you think. In the meantime, I'm going to try to figure this out also. Let's see. So we definitely need a bouncer up at the start. We definitely need a bouncer at this point. We can probably use another bouncer over here. Now, is this efficient? I think not. But this is the only way I can think of to do this. Now this looks funky as heck. But this is probably the only way. Ah, jeez, this is... Well, we just need 8 that's red on both sides. So I guess we can't use... Trash can would be nice, but I don't think we can use a trash can. Well, let's see how this works. I don't think this is any faster, and in fact I think this is much slower, and we're getting to our goal a lot slower also. We definitely need a decision tree up here and a decision tree down here. So red will always go here, red will always go here. We want a trash can. Anything else that's not red, even including red, will go into the trash can. Now, let's see. We have another balancer that we can use. So maybe this will take some data, balance the load. And then this will go down here and up here, and this will connect up here also. This looks funky as heck, but let's give that a try. Did I do this earlier? I feel like I did this earlier. Yep, I think I did this earlier. It's getting there, just slowly. Alright, then we're gonna... I guess this is where the copy paste comes in. This is iteration number 1. And this is working on our first iteration. This is what the GitHub thing is for. I'm sorry, CatHub. This is version control. There's a version that worked okay, but it is slow. And this is the version that we're trying to improve upon from the first one. Let's see. Maybe I'm going about this wrong. Instead of doing that, let's do the decision trees over here. And maybe the balancer after the decision tree. I don't know why you want to do that. I don't know why you want to do it this way. But that is the only other way I can think of that might work. Let's give this a try, see if that works any better. It's getting bottlenecked by the decision tree. This is definitely not working. Definitely not working. Alright. So we need another bouncer up here. I'm just curious, what does this do? Can we connect it like this? Does it make any difference? It kinda does. It kinda does. Alright. Probably not the most efficient way to do a bouncer. Let's give this a try. I don't think it's supposed to work this way. But I'm gonna give it a try anyway. Because we got 2 streams that we can work on. 2 streams of data. And go brr. At least it's not getting too clogged up. It kinda sorta did. Yeah, I think it's getting clogged up near the end there. Because I don't think this did anything to help the load. Now I can do 8. I can do it like this, where we split up the pathways in this manner, and that might actually work. Oh, what I could also do, I suppose, is I can probably trash some. Ah, maybe that's what I'm supposed to do. Hold on. Maybe that is what I'm supposed to do. So since there's too much data, we're gonna trash half of it. And then we're gonna get another bouncer over here. We only need 8 on this side, on each side. I feel like this is the worst possible way to actually handle the data, but we only need 8. So, in that case, try this instead. And we can use, I think, 2 more balancers here. There's 1, 2. We're gonna trash half of the incoming data, and we're going to split them this way. So not everything is going to make it. And then we're going to trash extra data this way also. So not everything's going to make it, which is a shame, but this is the best way I can think of how to work with it. Oh, and we didn't make our quota. We did not make our quota. That's a problem. Alright, let's try it this way then. Maybe this works. So we're still trashing half of our data. And it's still slow AF. And we still did not get all of it in there. Let's add some more trash cans, but that's not going to... 1 trash can. 1 trash can. And then another bouncer over here. To connect here. And connect this down here and connect this up here. So we're definitely getting rid of some data. Everything will not make it through. And that did us no favors. Maybe don't use the trash can down here at the end. Let's just put whatever. Put whatever. Okay, maybe I'm making this more complicated. Okay, so let's start at the beginning. This is gonna get clogged up as heck. And then any color that's not red will go down here. And then we'll just do balancers up the wazoo. Maybe that will work. Maybe this will work. Oh, okay, let's give that a try. It's gonna be slow. Too slow. That's too slow. Alright, let's try this again. Balancer up here. That gets the initial processing. Then maybe another bouncer on each side because we gotta keep it moving. Bouncer up here, bouncer down here. Hopefully this is enough bouncers. What did I do here before? And then another bouncer up here, another bouncer down here. And then we need a decision tree. At some point we need a decision tree. Now I don't know if I just need to make this work or can I get gold. If this takes... I'm trying to get gold, but I don't know if I can get gold at this point. There's gotta be a way to get gold at this point. Trash can here, trash can there, Annie goes down here, Annie goes down here. Another trash can down here, just to lighten the load up a little bit. And then we're gonna do all the inputs over here. I don't think this will work. I have zero hopes of this working. Yeah, that didn't work at all. We'll just go with the first solution. It's slow AF. And definitely quite inefficient. But how else are we supposed to get red in here? And I don't see any other way. I do not see any other way to do this. Unless I do two okay, back up. Unless I do two decision trees. So we'll connect here to the bouncer. We first need to sort this out really quickly. Get rid of this, get rid of that. And then we need a bouncer here, a bouncer here. Now this may not make a difference. This may make it more complicated than it needs to be. But if red goes up here and red goes down here, and then we trash everything else, maybe we can get somewhere. I hope so. The constraints are really, really killing me. That's the issue right now. I'll just go with the first solution over here. It's not the best solution. It's definitely fairly slow. Especially once we get to this decision tree over here. Let's take this. Let's delete this. This is no good. I feel like I can make this faster somehow. Let's go up here. If red. So bouncer goes over here. Can do another bouncer down here. Bouncer here, bouncer there. Maybe we can crisscross the wires this way. Does not make any sense. I don't know if that makes any sense. I will try to make sense out of it. I mean, if I do this in 8 nodes, hopefully that's at least a passing grade. Hopefully that's at least a passing grade. It just looks like a weird Oh, I didn't connect it. Well, I need to connect that. All right, sorting. We're getting reds, but we're getting them very slowly, especially once we get here, because it gets clogged up like no tomorrow. I feel like we need to trash some as they come out. That's the only way I can think of this working. Oh wait, I forgot to trash it over there. That's why. That's why it got stuck up there. And now we're not getting enough reds. We'll just go with this first iteration. I don't know how else to make this go faster. I really don't know how to make this go faster than it already is. We'll just release it as is. It's slow AF, but it does the job. It does the job. Alright, nothing new in Catbox. We still got the Metal Gear thing. Let's check Metal Gear really quick, because I don't think this is going to get any easier. Right, so for Metal Gear we need red circles and red squares, and green triangles and blue triangles. Now, how do we actually get them there? Because we're not getting any more than one shipment. And the sorter is not very good to begin with. So, if we want red for sure, they will go down here. All right, let's see. All right. If we get, so this is the main crux of the problem right here, this 20% error for the the 20% error rate to get to here. We got to sort through shapes first. You have to sort through shapes first. This is important. I'm just okay. So which one is faster? Shapes is slower. We can definitely sort through color easier. All right, so let's try this. Let's try this. If it's red, it goes up here. And if is at least green, it will go down here. Now blue will sort out one way or the other, which is not good. This is why we do this first. That's why we did this first. Let's go this way. Let's go blue circles and squares up here, triangles down here. If it's a red triangle, we want to trash that. If it's not red, we want to trash that. Now here's the issue. We also get triangles at this point from up here. No, we don't. Well, typically we don't. Typically we don't. So let's go ahead and send them out this way. And then if it is at least green, since it seems, no, let's go blue. At least blue, since we have more blues than green triangles over here. Let's send it out this way, and then we'll get random green somewhere. Let's try that. See if that works. And then let's do a test run. It's already at 2.5, so I don't know how to make this go any faster. Out of time, so we're taking too long to process this, it seems. So maybe we can do by color first. So let's sort by color first. If it is red, they go up here. If it is blue, they'll go down here. So there's some parallel processing that's happening also. Now green will go whichever direction it wants, and that is fine. So if it is red and a triangle, red and triangle, we trash it. If it is blue and triangle, we send it this way. Otherwise, we trash it. And we don't need this decision tree over here, because we can send it down here. Maybe this will work. Maybe this will work. The training's done. Let's sort this out. It's getting there, though it doesn't look like it's fast enough. We're definitely getting a bottleneck on we're definitely getting a bottleneck at the receptrons. So we're gonna need another decision tree on both sides. If it is red, keep going up here, and we will sort it up here. And if for some reason we get a green up here, we're going to trash it. Now we're going to send blue down here. If for some reason we get a red, we are going to trash that also. Now if we get a blue again, or green, whichever one, we will send it this way. And then the perceptrons on either side, if we get a square or a circle, we're going to send it this way. It should all be reds at this point, so no inaccuracies there. And send the triangles into the trash can, because we'll get some red triangles this way. Now, no, we shouldn't be getting any more reds on this side, so we'll be getting blue or green. So if we get blue or green, we can definitely send them down to this perceptron. And then, but if it's a green square or green square or a green circle, we don't want that. Triangle is going up here. They should be both green and blue. We should not be getting any reds. Let's give this a try. Now the only problem at this point is speed, especially on the bottom one. If we can improve our speed, then we're gonna need one more perceptron, aren't we? Okay. So we'll connect that down there. And then we'll send another triangle up here. And then we'll send everything else that's not a triangle into the trash. That should do it, I hope. That'll improve the bottleneck. It'll be slow, but hopefully this improves the bottleneck. That is the hope. That is the hope of our people. Oh, it's still too slow. This process takes a little bit too long. Not sure how to make this any faster. We will revisit this another time. We will revisit that another time. Save our progress so far. And we shall continue on the main tree, which is heritage protection. Let's see here. Let's give this a try. National Heritage Protection System from National Heritage. Good morning. We have dozens of scientific equipment placed in protected areas for the sake of looking after the objects of national heritage. Okay. We're parsing info from our equipment on a daily basis and need to sort it depending on the color of the report. Can you make a program that will help us? Let's give it a try then. And I only have a decision tree. Okay. And I can do it in 3. Oh, let's send it over here. Red will definitely go up here. No issues there. Blue will need to be sorted though, because we're probably going to get blue or green. Yeah, so let's sort that there. We'll probably get blue or green, and that's going to go down here. If it is green, it will go up here. If it is blue, it will go down here. It's kind of iffy. Let's use one more up here. So we'll definitely probably get some green up here. So if we do get some green, we'll send its way down here. That should work. I feel like this should work. Very nice, very nice. That worked quite well. Alright, so we got cat skins, Kugel glasses, and tank cat. I don't know what the reference for the tank cat is. I feel like I should know that. Increases data transfer speed by 5%. Yes, we will need that. Increases node work speed by 5%. Yes. DLL slots. I really don't know what DLLs still do. So I'm going to hold off on that. Node work speed. Yes. Transfer rates. Yes. Sockets processing queue by 7. Sure. Whatever that does. Entourage, Samsung X456. I'm not really a Samsung fan. Or Samsung. Samsung. I'm not a Samsung fan. I'll be honest. I'm more of a Sonic fan. Sonic fan. Yeah. Because battery life and they don't go boom. Messy hairstyle. Sure, let's do that. Still don't think the brushed up here is worth the 500. Machine learning will help the animals, okay? From animals. American scientists managed to develop a computer method for detecting the toxicity of chemicals, which is more accurate than animal testing. This is true. This is true. To create it, they use binary similarity coefficients, and the system itself was trained on information about more than 866,000 dangerous properties of chemicals commonly used in different experiments. That's it. It's interesting to know. Thank you for the facts. Alright, accuracy. Let's check this. Need harder ML jobs. Level up, maybe? Hi friends, it's me again. Hellraiser, thanks for those jobs. I can now afford a meal almost daily. But I need a kick butt video card to proceed with my tasks. Ergo, need more monies. Am I ready for a more hardcore job? Maybe. Little coders grow up so fast. No problemo, my dude Reno. I'll send some more contracts your way, with bigger data too. Beware, in these tasks, you're allowed to make some mistakes, but they're way more tricky to crack. How so? This is real-life data science for you. Corrupted data, incorrect data, useless data. When it comes to big numbers, it's not about being 100% correct. It's about getting the job done, Sonny. Alright, so there will be errors. We only have one node, and this is the proof of concept. At least we have a lot of data that's coming in. But at the same time, our success rate is only about 50%, which is what they want you to wrap your head around. It can't be 100%. Bid data equals big mess. Bid. Oh well, shrug emote. Shrug emote. Do those another time. We'll just keep going. Recognizing basic cat emotions at 69%. Recognizing speech recognition. It's private. A letter from a friend. BFF at Cat Meow. Hey, what's up, buddy? How are you? Listen, I know I wasn't paying you for quite a long time, and I'm very grateful that you weren't demanding for a paycheck for so long. But to be in debt even to a friend is not cool at all, right? Therefore, take this money you've honestly earned. Thank you, friend. You really helped me out. Yeah, and how about we go for a concert next week? Thank you, dude. I will take that cash. I could use cash. Alright, let's go for solvency assessment. Money bag bank. Client solvency assessment. We represent the money bag bank. We want you to create a system for sorting candidates applying for loans. We believe that cold, soulless mind of a machine will help us save more money than our regular empathy corrupted human clerks. Yes. We would very much appreciate it if you complete the task before the holiday, so we're going to make an auto trader now. So auto traders actually exist in real life. There's a couple of them that I know. Except I don't trust them though. I don't trust them, and that's a discussion for another time. Though they seem to be doing fairly well. But you know, it does work on an algorithm, so it could crash at any moment. I just don't trust it. Semi-supervised learning. Semi-supervised learning is used on partially unlabeled data with unknown answers. Great. Typically, a machine learning model predicts answers for unlabeled data and uses this prediction to improve. This method can improve quality of the model even when the data is not completely reliable. In real life, adding 5 to 10% of unlabeled data leads to minor quality improvement, and adding more data of this type spoils the model. Class A, is it a raccoon? Class B, unlabeled Class B. Predicted Class B. Okay, I'm not quite sure what I was trying to say, but we'll go with it. Alright, so we have 2 nodes. So for sure we want red up here. And we want blue down here. Now we're not always going to get blue. ちょっと待ってください。Wait. So green will go down here, right? But what about blue? Where will blue go? That's just gonna cause a bottleneck over here. Maybe, okay. Let's do this instead. So for sure we want green down there. This is the most that we have. And then anything that's not green will go down here. Now for sure we want red to go up here. And so we're gonna say red goes down here. But blue might go up top, or blue might go to the bottom. But we don't have as much error rate to compensate. Okay, so we want red for sure to go up top, because we only have 3 red and they need 3 red up here. So, we want at least green to go down here. Okay, there's a lot more green than there is red and blue. And then blue is 75% of green. So let's go down here and we'll send both green and blue down here. I think that's the only thing we can do at this point. All right. Go, 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 go. You will get a few blues up there, which is not good. Stop. Okay, so we want red at the second tree. So at the very least, we want red up here and we want green down here. Now what do we do with blue? We want blue to go down here. And if we get any blue... Okay, so here's how it's going to go. Green will go down here. Red will go up here. However... Now let's do red. So green will go down here, red for sure will go up here. Blue is a random number, is a random error. Blue random error can either go red or green. If it goes to green, that's fine. That we have some buffer for that. But if it goes to red, we definitely don't want it up here. So we'll send blue down here where green is. I think that will work. And it worked beautifully. There we go. Maybe that's maybe that's what I need to do to process the other stuff also. Lawn on a shelf. Cat's joy in case you run out of food. Okay. Not sure. Show in room, show in room. Hide in room. Yeah, we'll mess with that later. Alright, raging birds. I don't know if you actually need machine learning for this game in particular. Raging birds, almost machine learning. Angry birds. Mini piggy at cat. Raging birds from the sky. Dear computer specialist, you gotta help me. I own a miniature pig farm and also have a crazy neighbor. He enjoys making bird-shaped shells out of paper mache and throw them at my piggy sheds. He makes all kinds of shells. Tiny red ones, regular triangle ones, square ones, you name it. I'm constantly rebuilding my sheds so they would be impenetrable by those birds. But I need to be able to know the shapes of shells that Wacko's using. Can you please write an algorithm for that? What would this solve? I don't know. How would this solve anything? I guess it would make them more impenetrable, I suppose. Okay, so we have a balancer. Oh geez, we're gonna need 3 balancers at least. So 1 balancer for the top, 1 balancer for the bottom, balancer over here for sure. Balancer here, balancer here. And then we're going to need sifters. 4 sifters, I think. 3 sifters maybe. Okay, one thing I know. We have a lot of squares. We have a buttload of squares. So down here anyway, we only want triangles down here. Anything else goes over there. Anything else can go over here. And we are gonna get backlogged unless we use another sifter, it seems. So send that over here, send this over here. Send more triangles. See, we have 40 triangles to fill the quota. There's only 60 triangles. We definitely gotta use. We gotta sift first before we can balance the load. Alright, let's sift all the triangles first. So triangles will go down, and then we'll sift. Then we'll sift. All the triangles will go down here. All the triangles will go down here first. Else we'll send it to the balancer to sort out. I think that'll work. Wait, how many do we need? 30, 60, 100, and we have 180? I think that'll work. Okay, so 50% accuracy here, 90% here. Now, I don't know what kind of real-life model they're wanting in this case. But at the very least, we can send. Let's send some squares up to here, because circles, there's not as many circles. And then maybe another sifter over here. So we'll do an if else here. So we definitely need more stuff down here than up there. So let's send some squares up there, and then we'll send some squares over here. Else they go down here. No, let's send circles over here. Let's send circles up here, because I feel like circles are going to go up there. Alright, let's give this a try. See what happens. Feels like this might be on the slow side. We're definitely going to need some balancers up front, I think. Because this is not going to go fast enough. We might time out. That's the worst. Yeah, I think we timed out. Alright, so we're going to need a bouncer. Alright, let's first get a bouncer to sort everything. Now the bouncer is random, so I don't know which one's gonna go where. And then we get more bouncers over here. And then we will sift from here. Now I want at least the triangles to go down here. That much is for certain. Some triangles anyway. Then we need another sifter here and another sifter here. Now for this sifter up here, I do want to... So we can send whatever down here. We get squares, I want to send them up here at least. Send the bounce over there, send the bounce down here. Send a bouncer over here. Now what are we going to do with this bouncer? I'll probably send at least squares this way. And then anything else can probably go up here. Let's give that a try. That filled up quite fast. Squares, not going as fast as I would like. And we may have run out of shapes. Ah, crap. I forgot to do something here. Let's try this. Maybe that'll work better. This is definitely a blockage. I think we're running out of time and we ran out of materials. Let's look at that one more time to see where the problem is. Because this is going to be very RNG dependent unless it splits up the pieces evenly. Which I think it might. Yeah, we're definitely not getting enough triangles at the bottom. Though we are getting quite a bit of triangles elsewhere. Alright, so to do this, let's think of our connections. Let's think of our connections here. So for sure, I want to sift the triangles here to the bottom. That much is for certain. I want all triangles to go down. Otherwise, we will send some this way, send some this way. And send some this way, send some this way. I hope this works. Actually, no, that's not what we want to do. Because we want to send most shapes this way. And then we can probably send the leftovers this side. I think. Because if this splits up, this is 180. If it splits up, if it's this splits up 90-90, then we get 45 down this way. I think that should work. Now I'm gonna get enough triangles. I do not know. That is the question. Definitely not enough to answer that. This is a mess. I'm pretty sure I'm sending triangles here. Oh, I got an else here. That's no good. That's no good. That's what happened. Else needs to go up here, and this one. I think can go up here. Let's give this a try. Maybe this will work better. Hope I get enough triangles out of this. Oh, just barely. Seems to be almost good. I do need one more sifter here then. I do need one more sifter. Let's get a sifter up going over here. This maxes out our sifters. This sends extra triangles down there. And this will send the rest over here. Let's give this one a try. Hopefully that actually works in parallel as well as I think it does. Now whether I'm distributing the shapes correctly, that's a different story. That did not work. Why did not that work? Alright, let's do some analysis. 3 bouncers, okay, good. And then we sort that out. Triangle goes down here, good. Triangle also goes down here, which is good. We send some triangles down this way, and triangles again that way. Now, for the other ones, we send some shapes this way, which is fine. And then we send... This one only has one connection. It needs more than one connection. So we need 1, 2. Connections, and maybe let's give this a shot. I think my distribution is just not correct at this point. Oh, that worked. That worked. Well then, the trash can was a bait, because we don't want to trash anything. We can release this. Nice. Alright, let's see. I purchased items. Hawaiian room decor, sweet dreams, scientific assistant. It's a little bit too expensive right now. I don't really... Not a fan of either one. Oh, but we can do this. More complex structure than a decision tree, but I can recognize more classes. Good. Probably going to need that. Isolation forest, anomaly detector. Let's give that a try. Hardware, increase data speed by 5%, decrease server cost. You know, I think we can finally do the Metal Gear one. Hopefully. Ah, jeez, no. It's not giving us that option. It's not giving us the option to try the other stuff. It's whatever is available at that point, it seems. So when can I actually use those more complex stuff? Because I got some nodes here, but doesn't seem like I can use it, which is a shame. Nope. Sifter random forest. Guess we haven't gotten this yet. This node compares colors and shape of an element for each of the sockets and selects the one with the least amount of errors. There are several matching sockets. A random one is selected. A random forest is a composition ensemble of several decision trees. In real-life tasks, the number of trees can reach up to several thousand. Yep. Especially there's a bunch of stuff you need to sort out. Each tree can distinguish several classes, but they were trained on different parameters and classify objects based on different characteristics. When a prediction is required, a forest asks for the class from all the trees and chooses the winner by voting, picking the most popular answer. Ah. Is that something I can actually use, though? Well, it looks like the DLL slot is just for sandboxing. It doesn't seem like I can use this on any of our problems over here. So I'm kind of curious if that's actually going to come up in an actual thing. Well then, let me go for a little longer. My brain is saying go to sleep. Not necessarily tired, it just says go to sleep. But I'm going to go for at least maybe 30 more minutes. Let's see how this goes. Elite 3 at Cat. Oh, the meow is a little bit different. Elite Conference. Greetings. Our scientific conference provides several lecture halls for visitors to meet famous scientists. We would like to separate VIP badge holders from the rest, but unfortunately VIP halls have a very limited capacity. Therefore, some of the premium badge holders will have to be sent to regular halls. We have a terminal that helps visitors find the way to the respective room, but it has to be updated. Would you kindly do that for us? Well, let's see what we can do. Okay, so there's with the random forest stuff now, which I got. Okay, so I guess we had to buy it to continue. Otherwise, we wouldn't be able to continue. This node compares color and shape. Okay, we read this earlier when I was going through things. Isolation force. Didn't do this one. If the element satisfies both conditions simultaneously, end statement, it goes to the upper socket. Otherwise, it goes to the bottom. Okay, that makes it easy. Isolation forest is one of the simple algorithms for detecting anomalies, same as decision tree and random forests. Isolation forest distributes incoming elements into the leaves of the trees. The fewer questions it takes to separate an element from the rest, the more anomalous it is considered to be. So let's say in this example, if it's not a red circle, it goes below. Otherwise, if it is a red circle, we process it as normal. Can I use that here? Yes, I can, but not in Metal Gear, apparently. Metal Gear is challenge. Alright, so I can use 4 nodes, all circles up here, all green only down here. So let's do a sift for green, but I only need 10. And we have more than 10 circles, so I need to send some down here also. So I guess we have to sort by color for it. No, it wouldn't make a difference. It would not make a difference. Okay, so let's work backwards really quick. And we're probably going to need a bouncer at the start here, just to even the load out. So really quick. Immediately, I know I want... Let's see. I don't have any clause for the isolation forest. Random forest is compares color and shape. It selects the one with the least amount of errors. Okay. So I know if I want green, it's going to go down here. Otherwise, if it's circle, circle goes up here. Blue can also go up here, but we need the least amount over there. And they all have to be 100% accurate. So if it is a square or triangle, they can go over here. And blue, it seems we have the least of. So we'll send some blues over there, send some blues over here. What says about red? Red is not in our considerations right now, it seems. We need to do something about red. It has to be 100% accurate. Let's see. So we have 90 greens. Got balancer, isolation forest, sifter. So we only want green down here. So let's do a sifter's only shapes. So only green goes down here. Otherwise, they can go either top or bottom. Top or middle. Top or middle. If it is triangle or square though, they can go this way. If it's circle, it'll go down here. Alright, I think we can go and accept this one. And now we need another one for up there. So isolation forest will go, not isolation forest, we'll go random forest. So if it's circle, it will go up here only. Let's accept that. Now if it is square or triangle again, we will send them down here. Hopefully this works. Let's give this a try. Well, we're taking a hit on our accuracy a little bit. How are we doing on time? We are not doing well on time. There's some bottleneck going up over here. Ran out of time and low accuracy. That's not good. Let's slow this down a little bit though and see where the issue is. So it seems like we're getting some circles going up here also. We don't want that. So let's disconnect this. If we get we need shape sorters. So we'll send this here and here. No, not isolation forest, random forest. Set this here and here. If we get circles, let's send them up here. Otherwise, if it is squares or triangles, they can go down here. Now we might be pressed on time on this one, which is going to be the big issue. But this is the most accurate way to get this. But yeah, time will probably be an issue otherwise. At least accuracy is good. Accuracy is good at least. Now what I can probably do is get another balancer in here somewhere and send stuff through that way. Yeah, we probably need another balancer right before the decision trees to speed up the process a little bit. Let's save this though, because this is our best solution so far. See if we can fit a balancer in place on one of these other nodes. Alright, so here is the balancing act. So shapes are definitely the biggest issue here. Sifters. You can probably use a sifter here, if not a balancer. Alright, let's get rid of this one and this one. Because for sifters, we can... It's a little bit faster than a random forest, not that much faster though. But we have so many colors here that this is probably the best way to do it. And then as far as decision tree is concerned, we don't have a simple if-else. So a random forest or an isolation forest would be the next best thing to use. Problems there though, problems there. Alright, so we can probably do any here. Any will go there. Green will go down here, and only green. And then I can probably use another balancer here to make it go faster. Put a balancer there. Put another balancer here. And then load it up this way. I don't know if that's going to be any better, because this is going to cause a blockage. slow things down a bit. Accuracy is taking a hit down here. Why? Because we're getting circles also? Stop it then. So we're definitely gonna need an isolation forest or something. Yeah, so if it's green, definitely go down here. Otherwise, if it's a square or a triangle, go up here. Then connect this down here. Now, what am I going to do with this one? There's no trash can we can use. Though this does solve the issue as far as balancing goes. See if this works at all. Hopefully accuracy will at least be good. Speed is going to be a different issue. No, it did not work. Because I'm getting green circles. No, I'm getting circles up here. I'm getting circles from... Shouldn't be getting circles from up here, though. Accuracy is not good. Don't know what's going on there. This seems to be my best solution so far. Though the sorting could be better. I just wanted to try to get another balancer in here, then that screwed up everything. So the next best thing I can do is replace these random forests with sifters, because that's really all they're doing. Is sifting shapes. So circle goes up here and everything else goes down here. So send that its way. Circles, everything else. And then this one is also another sifter. Circles here and everything else. Give that a shot. It's slightly faster, not much better than the random forest, but I'll take it if it works. If it works the way I think it does. Though time-wise, it's not great. Time-wise, it's not great. I definitely feel like I could use another balancer before these decision trees are made. Let's copy this, replace this. I really want to see if I can get another balancer in here. And we'll probably need a balancer for this bottom one somehow. No, but if I do that, we need a decision tree. I need to put a decision tree here somewhere. Green will only go over here. So green will only go... So if you're green, you go down there. Capiche? If you're any color, including green, you can go over here. That's fine. However, if you're green circle, you go up here. Otherwise, green, well, if you're any other shape, You go down here in the middle. Now, I probably cannot use more than one bouncer, so let's not do that. I think this is as good as it's gonna get. Let's give this a shot. Still slows down here, but it's not as bad as before. The sifters are really... Okay, so that's what I was supposed to do. Alright, we will release this then. Congratulations. I want to at least try to get basic cat emotions completed. Get to this cutscene over here before we stop for today. Random force is greater than decision tree. Get in shop? Yes, I did. And also, I can't get this gradient descent just yet. Increases sockets processing queue. What is a sockets processing queue? Let's hide purchased items in this one. Data transfer speeds by 5%. I don't have the cash. Ancient sysadmin's tambourine. Increase nodes work speed. Okay, well, can't do any of that just yet. Presidential elections again. Mini Piggy at Cat Meow. Predict presidential election. Good morning. I need to know who to vote for. Can you predict the winner of the next presidential election? I will send you a big database. That was a thing that they tried to do back in the day. Yes, they did. And they still keep doing it. Because no one likes uncertainty. Alright, 4 nodes to work with. And we only want the blue ones. You would think this would be quick. But we need bouncer here and bouncer here. Well, at least one bouncer. And decision tree. So if it is blue, you can go down there. Also decision tree over here. If it's also blue, you can also go down there. But if it's anything else... Oh, wait. I need 300 blues, though. Or maybe I can just process anything that's not... 80%, so I can have 60 mistakes in there, so greens can also go there. Well, let's send some to the trash can and see what happens first. So blues definitely go there. But we need 300 blues to complete the sample though. Up. We're getting rid of everything that is not. So let's get rid of greens. And then the reds will filter through either one. Time might get us at this point though. Bouncer is being overworked. Do we need 2 bouncers to work this? Because this is accurate, but it is not fast. And we are going to run out of time. Alright, let's get 2 bouncers then. 3 bouncers. Because this isn't going to work any other way, apparently. and then, or one balancer. So we're going to have one directly do blue, and then we're going to have a another one over here. Oops, excuse me. I feel like we may not have enough balance. We definitely don't have enough balancers for this. How are we supposed to do this then? Because you want blue. For sure you want blue. Now we can probably send some red also. But we want all the blues at least. So we can send some red this way. But we want to trash the greens. We definitely want to trash greens. We don't want greens. Did I test this one already? I think I did. Yeah, this is probably going to get us on time. It's just too slow otherwise, I think. Ran out of time. Alright then, so let's think here. I'm gonna need a bouncer for sure. Now let's say 46 squares, 46 incorrect colors go over here. That is not within our mark, so that is still not good. And we definitely need a trash can. So we want only blue over there. If it is green, you send it to the trash can. We send it over here. Wonder if we can do 2 balancers. Would that make a difference? All right. For sure, I know I want blue here. We know we want blue there. We are probably going to get docked on time. But we shall do our best otherwise. So we'll send one directly there. And we'll send some over here. Unless I can do the decision tree ahead of time. Maybe that'll work better. Let's try doing a decision tree. This may not be the fastest way, but we'll give it a shot. Alright, if it's green, we definitely want to trash that. If it is blue, Let's try sending it through. Is this a balancing problem, I wonder? Let me just double check. Basic machine learning. Well, we're gonna get some reds, that's for sure. Probably don't need that if we're just gonna send it straight. Let's just see what this does. This is a time issue. This is simple, accurate, but we're gonna get docked on time. Doesn't process fast enough, nearly fast enough. So we need a bouncer to offload that. And then maybe we need a decision tree over here to send the blues. Maybe divert this. Don't know if that's a good idea. This is still the bottleneck, which is not a good idea. Send blue there. Send green up here, send it then down here. I feel like that's going to be the last challenge for tonight. Chick, 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 chick. So slow. So slow. Yeah, time is going to get us every single time. I can probably do it in 5 nodes, but yeah, that's no good. That's no good. We need a bouncer, but we can only do one bouncer. We can only do one bouncer attached to the input stream. See, this goes 40. So 43, so 40 greens go up here, and then once we connect it down here, there will be 15 greens. Then for the decision tree over here, we'll send the blues directly over here, and then maybe we can trash can some of this green. So this is not any faster. Let me just see what happens if I do one more decision tree here. Definitely send the blues this way, and definitely send greens to the trash can. This is roughly what I expected the accuracy is going to be with 5 nodes. And this should process it quickly enough. I mean, it works. Not the best thing in the world, but it works. All right. See if we can improve this. So 46. So we're getting 46. Something tells me I can't do 2 balancers here. I need to do only 1. The balancers have to be at the beginning, otherwise it doesn't make it. It won't make a difference as far as processing time by the end of this. All right, how would this work? Green goes down there. Blue will always go up here. So this is the one that worked, but it took 5 nodes to do it. Let's try to get it in 4. So let's send... Oh no. That just clogs it up. What if... Can I do this? I can. It will be circular. But we can just keep having the greens rotate. And I think that'll... No one said we couldn't rotate the greens. You know what? This is so funny. It might actually work. Let's give this a try. We're just gonna rotate the greens in the system, never actually getting over here. It's slow. It's definitely slow. I don't think it works too well. All right, we can try. We can. I think that's an answer. It's not a good answer, but it's an answer nonetheless. All right, so green. Let's send it back to the front. Blue will go over here. Bouncer. You know, I think we'll run into the same issue here. But I'm kind of wondering if this weird contraption of circulating things will work. It clogs this up, which is the main issue. Regardless on how we deal with the reds and greens, it clogs this up. All right, let's send this then. We definitely need another bouncer here, but all right, let's try this again. So the working solution had a bouncer in the middle. But let me see if I can do without a bouncer in the middle. And we'll send the greens back to the bouncer. I think I tried something like this with a trash can, but it didn't seem to work that way. It did not want to work this way. Oh, wait. Why did I have reds there? No, that's not right. That is not right. Time issue again. We definitely need another bouncer in the middle. But I think this might kind of work. Maybe. Probably inefficient. Let's give this a try. I mean, I don't know if it works or not, but we're definitely getting caught on time here. That's the main problem. That's the main problem. I think we need 3 balancers. There's no other way this could work otherwise. And then we need a way to get blues sorted. So if it's blue, definitely go there. If it is green, send it back to the front, and maybe send these balancers back to the front also. It's funky. I don't know if it works this way, but let's see if it works. No one said we couldn't do it this way. It's slow AF. It is very much slow AF. I don't think it works that way. This is a working solution. Ah, jeez. I'm just messing around at this point, trying to figure out what can work and what can't work. It's pretty hilarious. It's pretty hilarious though. Okay, let's get rid of these. But if I had my way, I would probably do something like this, but that's 5. That's 5 nodes, and that already is not good for a gold. And we'll just send the greens back in the front and have it keep circulating forever and ever. I mean, the biggest issue here is the decision trees are slow. They are very slow. But we need to somehow get blues into the system. And the only way I can think of doing that is do this. This is probably an unnecessary step at this point. It doesn't save any time. You want these things to go in parallel. So over here and over here will be in parallel. But time-wise, we just can't do it unless we get a better system or something. It's just not going to happen otherwise, I don't think. We do have a balancer here, and we're sending some directly into the system, which we could probably still do. So we'll send some there, and then we'll route this back. Maybe this will work. Maybe there's only a slight inefficiency on the top decision tree. The bottom one is going to be as efficient as possible. but it is slow, and this got clogged up. The bottom one got clogged up because I did not send green back into here. This is so funky. I don't think this works though. This is on the right track, but too slow otherwise to work. Maybe I just have to go with it. Maybe that's the only solution to this problem at the moment. Because otherwise, this problem takes too long to do. Let's see. Let's just get really basic again. Let's get really basic and see why this does not work. Why does this not work? Because you would think this very simple solution would work. But you do have a bottleneck over here and a bit of a bottleneck over here, but this is not as big of an issue as this one in the middle. Here you run out of time, when you can simply probably send some of it directly into the system. Now we can't trash everything because we do need all the blues. We do need all the blues. So if it's blue, we'll send it there, but if it's green, maybe we can send it back into the system. Did I try this before? Because this works, sort of. It's just we have a bottleneck. Oh, and I stopped it there for some reason. Let's send it back this way. It's like send them back to the start of the line. Kinda sorta works. Actually, let's not do it this way. Let's send the greens this way. Maybe? I don't know if that's any better, but this is definitely... This is the huge bottleneck for this instance. We definitely need 2 decision tree colors to go this way. We need all the blues to go over here. We can let some greens in, and we can definitely let the reds in. Our margin of error is 60. So if it's 60, so this goes 46, 43, 43. Well, 40, 40. Let's say 40, 40. Some greens will go here, some greens will go there. If that's the case, we can let all of this, anything that comes from this side, you don't even need that. You can just send them directly into here. So that's 43 greens that can go there. If that's the case, we can send any stray greens from here into the trash can, and any reds that make it through from here will be a-okay. Maybe this will work. We're just waiting on the blues though. I think that's the big issue. So this kind of works. Now maybe we can do one more thing. We can do another balancer. So we have 40 greens going this way. We can definitely send some from over here. However, we need to sort them out and send any extra greens back into the system. If not, outright trash them. See if this works. I'm a little bit worried about accuracy at this point. Huh? Why did it stop? Ran out of time, low accuracy. Okay, I guess we just need to actually trash the greens that we intercept from this side. That's probably better overall. That's what it wanted me to do, apparently. Okay, we'll release that. Holy crap! Really? Really? Alright. Let me just check what's up in Seabay really quick. Transfer speeds, 5%. Server cost. Increase data transfer speed by 6% for 200 more cat bucks. I don't think data transfer speed is what I need. I need node work speed. Node work speed or no our data transfer. Let's take one data transfer for now. And I did say that was going to be the last one. However, I do want to give the Metal Gear one more try. Knowing what I know now. Let's keep this. It doesn't work, but let's keep this. We're going to scrap it anyway. Alright, so mark perceptions over here. We want to... Well, let's get this working first. I think here the issue was it's too slow. It's much too slow. We want our fast ones over here. So we have a 60% error rate. We can let some green and blue. We can let some green and blue circles and squares. We cannot let any red ones go through. Scrap this entire thing really quick. Okay, so how many of each do we have? So we have 30, 70, 85, 85 errors. 85 errors. 35 that need to be correct. So at most, we can have 14 errors. Okay. I'm probably too sleepy to tackle this right now. So I'm just gonna end here. We're gonna go ahead and watch this movie and end the stream right here. Alright, so we got gold. Huh. I wonder what this is. Let's go silver for now. Neural computer vision. Hold still there. Science is at work. Set true predict. Okay, I'll take it as a smile. Smile 55%. I think we're on the right track. To-do list. The cat has been detected. Base cat emotion recognition. Checked off. Nice. Alright. Go recognize cat emotions. Somewhat worked. Somewhat. But we're gonna call this a day here. Alright, so we did quite a bit today. I think it's important to do some of the side quests at least if you want enough cash for upgrades, but I think going just through the main quests is good enough for now. It's good enough for now. Genetic algorithm is what we're going to go off next time we do the stream, but we're not going to actually pick this up next week. Next week, I am going to do a different game, something I've been wanting to do in April. Stuff happens in April, so I'm going to start that. We're going to alternate between that game and this one. For next month. So we're not going to be doing this until maybe a couple weeks later, and then we'll pick it up again, and then we'll do something else. All right. I know that was a lot of thinking, guys, a lot of technical stuff, probably that more than you're used to. But compare this to some other puzzles. I think it doesn't hurt to try this once in a while. These kinds of things, because it is interesting. At least for me, it's interesting. And Cat is being very smug right now on top of the shelf. All right, well, you can keep being smug, and we'll deal with you later. Anyway, guys, thank you for watching, and I hope next time we can get a little bit further. Hopefully, we can get through some of these processes a little bit better. I think I'm starting to understand some logic as far as being okay with errors, especially this. The 60% error rate is gonna get me, but it's like 14 incorrect specimens into the output stream is, I think, something I'm just gonna have to get used to off the top of my head. But I mean, it is what it is. And in real life, machine learning is a very messy thing from what I understand, and we're just going through this mess right now. But so far, I'm enjoying it. If you like puzzle games / some actual science machine learning thing, this is the way to go. I think, well, not the way to go. At least this gives you a primer on what to expect as far as the thought processes go in this kind of programming. And we might do some actual programming on stream. So just simple stuff to get our feet wet. Anyway, thank you all guys for watching. Hope you enjoyed it. I know it's a lot of thinking. Next time though, we will be doing a different game. Tomorrow is our weekly atelier stream. So hope you join me for that for Meru. And I'll see you guys next time. Have a good rest of your day.